Okay, let's look at this thing. I see. So distribution. Okay. Where's it set up? But since it's greater than this is greater than this thing, you're good to go. Oops, there's still rest. Oops. Run it. Instagram, man. That should work. Oh, I see. You have to load this guy first. Obviously, right? numbers, 1 plus 1. You could also do this one, right? It's 2. You could also do print 1, 1 Google 1. It's true. Boolean. You can put comments. It's the same thing. You just do it doesn't print, right? Comments. What else can you do? So let's do. Let's see. Let's do. Hello? You hear me?
Hi,
Hey, how's everything? Okay, the coding and everything, how was that? Like, I know there's a lot.
yeah,
Okay, that's good. Yeah, we can do that again. If you send me the quizzes for next week and then like the R coding. Oh, it's due tomorrow? Okay. o- Okay. Yeah, just send me that and like let me know when it's due. Okay. I can do that for you. Okay. For that one, because like for these, I would really like to like show you, I guess like, maybe we can like do it together. Uh, yeah. Okay.
yeah, I mean the data you build.
Okay. We can try doing that. If there's something there that like that we need to talk about,
Yes.
let's talk about that one.
Okay.
So like, because you mentioned to me that there's a. Can you see my screen by chance?
Yeah, I can see you starting to study.
Yeah. Like I was just gonna tell you like maybe basics of like. Do do you by chance have R Studio or are you working with just?
Yes, we are working with our
Okay. Yeah, that's good because that I'm used to this usually, like because like you could work on R, but there's just not a lot of it's not very friendly.
or it's not very
Yeah, because like a lot of it is you know how like computers you have to do a lot of commands, and then there's not you don't just click and it's you know. But then if you have like R Studio, it makes everything easy and then easier to interpret. But what did what did your professor talk about already in terms of like did you guys cover like data types and statistic commands?
Yeah, we covered data type, that
Yeah, yeah.
yeah, my own world.
Yeah, I know what you
So
mean. I'm like, it's very much like coding is really difficult. Like for if you haven't seen it a lot,
yeah,
well,
I've never seen these kind of things before.
we can. I think the best advice I have is you know how like we're because the class is it fast paced or
Yeah, it is fast paced. It's 7 weeks long,
okay, wow,
and
okay,
it is done online.
okay,
And
that's
yeah,
fine. Yeah, um, it's yeah, like I always say that like with coding, it's not one of those languages where you can just like conceptually take it in.
yeah,
You know, like read the lectures and that's it, right?
yeah. Because that's what I'm used to. Because I'm an arts person, so I'm used to reading things. I do what arts and stuff like that. Now I'm trying to push my
Uh,
head in program.
okay,
Naturally,
okay. I know, I
something like that.
I know what I mean. Okay, I'll let's I guess let's go over like overview in terms of like maybe the basics of R first. Uh,
Yeah. So.
let me just take a because what you can do with R is like a lot of things. If your professor already talked about it, is like R is like the main language for data science. Somewhat. There's also another language called Python. You can learn Python later on, but like R is definitely one that you could use for data science and statistics, and then because it already has like a lot of packages, everything is like open, and then like there's about like 9,000 plus packages that you can program in R. You can bring in and then like use their commands. And and then I gotta say, like if you're gonna be using R, there's there's documentation on it. So
Mhm.
like if you ever go like to Google and just say like if you don't know how to within R itself, if you're like just to show you like this is probably familiar, but like if you don't know like a particular like command, you can just do this like question mark and it gives you a documentation here, right?
Mhm.
So like if you were to use it, then it tells you like do you know what an argument is? Like arguments for commands.
Well, here's what I think.
Okay.
Is it when you put the pound sign?
The what one?
When you put the pound sign, is that a comment or a value?
The pi sign.
Yeah, the pound sign, like the thing you put in Twitter, pound thing.
Oh, the pound sign. Oh, yeah. That's a comment. That's a comment. Yeah, this guy.
There's a comment.
This guy, right?
Your screen is very
Can you see it now? I don't know if I can even zoom in. Let me see this one. Zoom in. There we go. Let me know when it's like good size.
it's not coming to this TV. On my screen is
Oh, that's weird. Let me just re-share that. It's probably this guy. What about now?
still there's something somewhere.
You should be able to see my screen now.
It's still
Oh, did you go to Skype by chance? Okay. Try to. Oh, okay. Try to go to I sent you an email. Try to go to your email. Yeah, I usually use Frog just for that makes sense. I thought you were already in I thought you were already in my Zoom. Okay, let me send you this actually here. Do you have Zoom by chance? Okay, just click on this guy, and then like you should be able to come into my Zoom. Let's see. I'm just gonna post it in here. Here you go. I just copy that and then put it on your website. Yeah, just the last one. Yeah, just put that in Google Chrome or whatever browser you have. Okay. Yeah, all this time I thought you were looking at my programming. That's why I was like, what are you talking about? Oh man. Okay. Okay. Did you try go to your email? And then I'm just gonna send you the link itself. It should be clickable now. I think it's like hyperlinked, yeah. Okay. Okay, do you see the link in the email? Okay, that's good. Okay, that's good. Okay. Did anything pop out yet? Okay, okay. Okay, it should say there's two people here. Let me see. So this class is like all about statistics, or is it like just is statistics just a tool? Let me see. Okay. Is it still loading?
Yeah.
Okay. Hmm. Okay. I think I see it now. Do you see my screen?
You see me coming?
Yeah, it says two people. I saw your message. think you should be online. I'm sharing my screen. It's the website as well as like R. Is it coming through?
Yeah, I see what.
Okay, perfect. Okay, I think I'm gonna exit out of this because like my voice is on the other side. I'm gonna exit out of it. Can you still hear me? Yeah. Hey Mary, can you hear me? Turn on your I guess your mic on Skype or Zoom. Yeah, because like I think there's like a echo.
Okay, can you hear me clearly or there's echo?
Okay. Okay, now I can hear you.
Okay, thank you.
Yeah. Now usually like if I turn on Frog and then as well as like Skype or Zoom, it usually does that. Okay, I think we're set. I
Yeah,
think we're
yeah,
set. Yeah. Can you see my screen?
yeah, yeah. Now I
No.
can see the screen very clearly.
All right, perfect. So like I just wanted to go over because the thing here on the right here, like all the commands. Like I can probably set up my own, but since of like the for the next one, I
Mm-hmm.
usually do is like I try to create a notebook. But let's just go over like basics of R, and then maybe if you have R or open, you can go along with me while
Okay.
I'm like, doing this. All
Yeah.
right, let's take a look at this guy. So like in R, uh, you already know that like when you put in a hashtag, that means it's a comment, right?
Yes. Mm-hmm.
Yeah. And then like you can print different things in R. Like you have like maybe a string. So all you have to do is like maybe print. Like print is like your best friend because it outputs you like if you were to do this right here. And you know how to run commands, right, in R?
I normally I use Control Enter
Yeah.
because
So that
sometimes when I click on the R button,
yeah.
nothing happens. I just kind of like don't see anything in the console window.
Yeah.
Sometimes I do, but sometimes I don't see anything there.
Oh yeah. Okay. So what I would so like for this one, do you know about the print command? Like like the print command in that I'm highlighting here. Yeah. Do you? It's because yeah, you probably have Frog on.
My speaker?
Yeah, I can hear myself twice for some reason.
Yeah, because I can hear you.
Okay, let me see. Because I'm gonna exit out of like Frog. Can you hear me now?
Yes.
Okay, we're just gonna stick with this one. We don't need to,
Okay.
because like there's gonna be a lot of echoes. Okay, can you see like what I'm highlighting here?
Yes, I can see where your cursor is.
Okay, so like in R or any programming, there's a lot of data types. You have this like if you put like this apostrophes, right, or like maybe like a quotation marks. Like this just says that this is a string, right?
Mm-hmm.
And then like how you can test that is I think it's like class. Yeah, it is class. Let me say class. And then see like it tells you that it's like this thing is like a character or a string. I usually call it like a string. And you can also do like operations, right? Regular operations, like 1 + 1, and then -1, and then I think there's we can even go over those ones. Let's see if there's like one that seems So you guys went over like how to do some math operations like multiply and divisions.
Yes.
Okay. And then like you can even do uh, like exponents. So maybe sometimes like those are not that known. So like maybe 1 squared, right? You can do this. And then just run that one. And that's right. And right here is like where like so that is 1. Or if you've heard of Boolean, do you know what a Boolean is?
I think it's the true, logical true or false.
Yes. So like that's right, yeah. So when you, for example, this guy, like line number 5, I run this guy. Let me just explain it first. So this is saying is 1 equivalent to 1. So this is asking is 1 equivalent to this guy. It must be true, right? So let's check if it's true. So that is true. So that's a Boolean. Like, every time you're comparing something, maybe if you have like less than, then it's false, and then this guy, and and then there's a lot of those. What about creating a list? Did you guys talk about creating a list?
No, we didn't talk about creating lists.
Okay, so one way you can do that, it's a little like right now. I'm gonna say like the way you have to, like usually when you say like something is equal something, right? Like this guy. That's how you typically do it. But in R, it's just like left or less than sign and then like a subtraction sign. It's like an arrow, right? And it this means like I want to assign something to this variable, right?
Okay.
Yeah. So like what? Do you know about that? Like when you're trying to assign something to a variable?
Okay, so that's where I would like you to clarify.
Okay, good. Okay. So when you're trying to assign something to a variable, like for example, I want v to equal like 1. Like this is how you do it. Like and then let's like v equals 1 and then let's try to print what v is now. So you see this? Like this is a variable, right? And then I want it to equal 1. Like that's like what you as a coder want to do. You want it to equal 1. Then you just use this arrow, symbol, like how you write that or type that is less than and then subtraction, right?
Yes.
So when you do that, then you're assigning whatever this number you put on the right of this arrow into like the variable on the left.
So the left one is what we call the variable.
The variable, yeah. Yes.
Okay.
Yeah. So like this is pretty much like like if you were to think about it, I'm pointing to the variable, and then anything on the right, that's where I'm coming from. Like I want to put 1 inside v because it's pointing to v. That's like it's going from 1 to v. So do you understand this one? This is pretty much like I'm gonna put 1 inside v, and then now v equals 1. And then you can do many of those. You can do like maybe x equal like 2, right? And then like and then the way it doesn't, you don't know what it is until you print it, right? You don't know what's inside this guy, right?
Oh, okay, got you.
Yeah. Right now you
So
assign
when you print is when you are knowing what is in it.
Yes, yeah, you got it, yeah. So like this thing, is this familiar, the R Studio, like the colors?
Yeah, the colors are familiar.
So like and then also, so this is where your script is, right? This is your script.
Yes.
And then right here is your console or like your output.
Yes.
So like on the script right here, I'm just gonna comment these guys out first. I'm gonna comment them out. So, when you run this, when you run these guys, it appears down here, right? But then the thing is, this is the blue just tells you that you're running something. Like, look at this one. Now I'm gonna print something, right? I'm gonna run what I have in print. And it has this value right here. This 1 and then 1 and 2, right? Like anything in black is output. Anything in blue is like you running the script. So like these are the outputs right here. Is that gonna make sense? Like this is how RStudio does it usually.
Okay, so output in console window.
And then you every time you want to check something, you always want to print that variable. Okay.
Okay.
So for example, let's try to do something more complicated. Like so now what is V? What is X? What is V? V is 1, right?
Mm-hmm.
And X is 2. So what if I wanted to like add the variables now, right?
Mm-hmm.
You could just do that, right? Like you could just do this V plus X, and then maybe I want it to equal Z. So that's how I would do it, V plus X, and then I want to put it in Z. Does this one make sense? Like I'm trying to get these two variables. I know that they're numbers now because it says it right here. They're numbers 1 and 2.
Yes.
So I want to make them equal. This is like an equation now. Like I want to make them equal Z. So like you can print that as well after you run it. Obviously, run that one first, then print it. So you see that's like it shows up right here.
Mm-hmm.
And okay, so that's a like number, like one element of a list. Let's talk about a list now. Like, so for example, what if we had like A, and then you want our, I guess I'll just use the same one. What if we had V, and then when you're creating a list, you have to do this. So a lot of code, you just have to remember how they look like. So sometimes like, why are you doing that? It's a little like uh, funny, but it's just like the language, like they call it syntax.
Mm-hmm.
And then like when you're creating a list, this is just what you have to do. Same thing here. What I want to do here is I want to create a list, and then I want to assign that to V. So V is gonna be a list now. Sometimes when I try to do these things, I am, like creating variables.
Mm-hmm.
I like to make them more descriptive, because then like once you're trying to do something with them, like what we did here, like V plus X, sometimes I have no idea what V is, right? Just by looking at this and then not looking at this guy. Like if I had this information, I don't know what V and plus X means. So what I usually do is like I try to make the variables descriptive as possible.
Okay.
So this one, like V list 1. This is the first list. So how you create a list is you put C right here,
Mm-hmm.
and then parentheses, and then what you put inside the parentheses is like the numbers, of that list. Does that kind of make sense? Like so like now I wanna let me output this guy. Uh, so here. So if you look over here, I ran this guy. So you had this V list 1, right?
Mm-hmm.
And then this V list 1 is this is how you create a list. You put C, and then you have all these numbers inside.
Mm-hmm.
And then like I want to check what it is now, and then this is the output. It's just a list of things. 2, 5, 6, and 9. Yeah. There's 4 things in here. That's why you could put like this is the output now. Oh yeah, I sent you a video. Like it's some of these not clear. Maybe that video will clarify some of them.
Mm-hmm.
But yeah, this is how you create a list. But let's move on. The next thing is let's create another list 2, because I wanna be able to do something with these 2 lists. So list 2 is 8, 2.5, 14, and 9. So you have this guy, right? And it's gonna be kind of like a similar one. So let's just let's not print these ones. We already know what they're gonna look like. So let's just run them. So they're already set, so it's like blue. And then so when you create, maybe like I want to compare, you know, for every element, you know, these guys, there's like 4 of them, right? Like list 1 has 4 things in it, and then list 2 also has 4 things in it, right? One way you can like maybe operate on a list is like compare these 2 things. Like if this guy is like greater than these guys, and then it's just like, you know, it's just it's gonna give me true or false, right?
Okay, which means you could have decided to use B is less than T
Yeah, you could do less than or greater than. It doesn't
or
matter.
greater than. Okay.
Yeah.
Okay.
Let's do less than. So let's try like run that one. I don't know what happened here. Let me see. Oh, I see. That's the wrong one. Let's say that's because there's no T. It's list 1, obviously. That's why there was like an error. List 2. There you go. So you see what happened here? It's like I tried to compare this list to like this
And
list,
that list.
and it just, so it's a list of numbers now. It's not just a number. So that's why you have like true, false, true, false. Because if you compare what 2 and 8, then like this 8 is greater than 2, or like 2 is less than 8. Okay, so that's technically a list. You could do a lot more. Let's just talk about maybe, yeah, let's look at this one. Oh yeah, there's another one that like lists. There's also this guy. So like when you wanna like do like maybe this. Let me see if this one works. Let me just print this one out. Okay, so that one doesn't work for it. Okay, so when you know, what if you wanted to create like a list of things like from 1 to 8? It's still a list, like, right?
Mm-hmm.
But then like now I'm just trying to create, instead of like doing what I did here, like which is like a bunch of like uh, numbers, and then it's like all hard coded.
Mm-hmm.
I just want to create like a list, but not, I don't want to put in like one. This, you could have done the same thing by doing like 1, 2, 3, right? 4, 5, 6, 7, 8.
Mm-hmm.
But then it has to be. Hold up. Oops. Hmm. That's weird. Okay. So when you do this one, there you go. Let's change 8. And this one, there you go. 4, 5. And this guy. All right. So like you could have done this list the same way as like what I did here. Like this 1 to 8.
Mm-hmm.
But then, you know, when you're writing this guy,
Mm-hmm.
you're just given like a range. It's like a syntax again. Like I want to start anything on the left of the colon is where you want to start, which is like this one guy right here.
Mm-hmm.
And then 8 is the last number, and you're going, you know, it's like 1, 2, 3 all the way to 8, right?
Mm-hmm.
Because like if you keep on doing this right here, it's just gonna take. What if you had like 100 numbers, you know?
Oh,
Right?
okay.
What if you had like 100 numbers? This one is quick. This one is a quick one.
Mm-hmm.
And then is the output does this one make sense? Like, you know, this one says 1, and then this one says 12.
So why is 1, 12, 23, 4, 34? Why are they in that bracket?
They're in a bracket because it's pretty much saying like this is the first one, which is this guy.
Oh, okay.
Like the first, it's like an index. It tells
Okay.
you, and then when it said like, so 1, 2, 3, this is the 11th guy, right? Like
Mm-hmm.
1 to 11. And then when you go here, this is 12 index, which is this guy.
222.
Yeah, and all the way here,
Okay.
this is the hundredth. So 99, then all the way. It's just telling you what the index is.
Oh, okay.
Yeah. So like sometimes when I look, cause like they kind of just it's a little confusing at first, but like, oh, that's what it is. Okay, let's talk about something else. So that those are all about lists and operations. Let's talk about what's a good one. Well, we talked about lists, so there's a list here. Have you guys talked about matrices before?
Which one?
You guys want to know where a matrix is?
You asking if we have talked about which one?
Matrix.
Yes. Yeah.
Okay.
That was just some exercise they gave us, like a practice, like in data camp, something like that.
Okay. It's not as important. Maybe that's maybe like something more related to like statistics is like something that maybe it's easier to see. Oh, like okay, data frames. You can talk about data frames.
Yeah,
Have
he
you guys
said
talked about
data
that?
frame.
You guys talk about data
Vector.
frames?
Yeah, he said data frame, vector, list, and factor.
Okay. But before that, like maybe let's see, because I really wanna do like a loop, maybe a loop. What about loops? Have you guys talked about loops?
Yeah, he was talking, but I was not even understanding it.
Okay. Okay, yeah, because it's really sometimes it's a little complicated to see what that is. Let me just look for one where here you go, if statements. Okay. Okay, let's talk about this one. So there's two types of struct. Like the one thing that we talked about variables, right? Like we talked about lists and variables. And like the reason, and then we talked about like comparisons right here.
Mm-hmm.
There's like comparisons. Oops. Comparisons. And then I'm just touching on like what some of these like structures. They call this programming structures or coding structures. They're very important. What are data types? What are comparisons? What's a list? What's a variable? And there's two more that's like very important for before we talk about like the actual commands for statistics. Or there's what we call conditional, and then there's one called loops. But let's talk about conditionals first. And this one is composed of like if, else, if, and then else statements.
Mm-hmm.
And so for that, when you're trying to compare, something like if this guy is like 1 is less than 2, you usually do it like this. So let me just give you the structure of it. So you're let's say 1 is less than 2 here, and then maybe and then how you do the syntax here is that this is how you usually do it. So you have that guy. Let me just type this like some example first, and then like maybe inside this thing is let's say print. You are correct, I guess. and then so let's try doing this one. So let me just run in this first. Okay, so it does run. So when you're trying to do an if statement, this is the syntax. You put in an if here, right?
Mm-hmm.
And the next thing you put in here inside the parentheses, you've seen this before, right? This is what we did right here.
Mm-hmm.
So anything you put here it's called a conditional, like a comparison. It's called a comparison. Um, and that's why we learned about it so that we can actually use it. And that's why it's asking you if you read this, it's asking you if 1 is less than 2. This is what it's telling you. If 1 is less than 2, right?
Mm-hmm.
Then is that correct? Is 1 less than 2?
Yes.
Yes. Okay. So that's the question that like if statements always you want to ask, because then if it is true, if this statement here is true, then it runs the next line. And it did, right? It ran the next line right here, right?
Mm-hmm.
But what if this is not true? Let's make it false. So like if 1 is greater than 2, we obviously know that's like incorrect, that's false. So the first one was true. If 1 is less than 2, then it's true, it runs it, right? It ran this guy, right? But then what if it's false? Now it's false, let me run this one. Okay, so I ran it, right? This thing right here says I ran it, right?
Mm-hmm.
But nothing outputted. There's no output. Why is that? Do you know why?
Because it is not true that 1 is greater than 2.
Yeah, you're right. So it's false, right? So if this one is false, then it doesn't really run what you have inside the curly braces. Does that kind of make sense? Like if that's really what a if statement does, is it just checks what you have here outside the braces, and then if it is true, then it runs it inside the brace. If it's false, it doesn't run it. It goes to the next one.
Oh, okay.
Yeah, that's pretty much what it's doing. There's another one besides that one. Let's do an if-else statement. So what if what do we have here? So like, let me just type this one in first. So this is just an extension. So if this is the case, if 1 is greater than 2, run this, or say you are wrong. All right, you are incorrect. Okay. Okay, so now that we learned about if statement, let's add in the else statement. Okay. Do you see this one?
Mm-hmm.
Okay. So like this, so the if statement, does it make sense for the if statement?
So if you say else, print you are correct. What do you mean?
Okay. So like anything here is just arbitrary. I could have just done this, it doesn't matter. It doesn't matter what I have in here.
Oh, okay, got you.
Yeah.
You can put it
This is
wherever.
this is all arbitrary.
Okay, got you.
Yeah. Like I'm just trying to like use this as an example of like how to. Okay, so when you run this guy, right?
Mm-hmm.
It's not gonna run this guy, right?
Mm-hmm.
Because this one is false, right?
Yes. So there will
Okay.
be no output.
There'll be no output. But what if I wanted something in there? So maybe, what if I want to do this change if statement? Like okay. So like, what if this runs and it doesn't output your print statement? So and I don't want this thing to not run. So what the other thing you can put is an else statement. So if this is not true, right? It's false, right?
Mm-hmm.
Then it's gonna check your else. So if the if statement isn't true, it's gonna go to else because else doesn't have a condition. It's just everything else, Right? This is gonna make more sense once I put in like an else if.
Mm-hmm.
But okay, so a lot of the conditionals if, else, if, and else, and I think there's like another one, switch. A lot of these ones, you have to understand kind of like the flow. Um, I think sometimes it's better for me just to explain it rather than using a flow diagram right here. This is the flow diagram. Like it's kind of small, but that's what it is.
Mm-hmm.
But so if you're just to reiterate, so if your if statement condition is true, it runs this guy, right? If your if statement is not true, it's false. It doesn't run this, but it runs your else statement, right? Your else statement doesn't have a condition because it's pretty much if all your if and else if are all false, then it runs this guy. So let me try running this. So yeah, once I ran this guy, the only thing I have is this string right here. It says change if statement, which is what we have here, right?
Mm-hmm.
And then the reason why it ran is because the if statement is false. So that's true, right? Like we know that one.
Yes.
Okay. So do you understand what the if else statement does now?
So you are saying that if it is false,
Yeah.
then or else print that change thing that you did. So that's why we only had one output for
Yep.
the else.
Yeah. So like if you the only time that you all of these guys
Mm-hmm.
inside like everything after if
Mm-hmm.
inside these curly braces are the code that's like with the if statement. It's associated with the if statement. Like it's inside these curly braces. I could have just done this. Like this would have been the same.
But you
But
have to run them together, right?
you have to run them together, yes. I usually did that here. This is the syntax aside, which is like sometimes weird, but it's really the curly braces throw people off. You know these curly braces?
Mm-hmm.
Because the way this is like written is you have this curly brace and then you put the print or the command that's associated with the if statement right here. And then you have this other curly brace, right?
Yes. For the else statement.
Yeah, for the else. And this one right here though, and then else this is the curly brace that starts it, and this is the curly brace that ends it. Does that kind of make
So it has three curly braces.
There's in essence, it's like I usually call them like in pairs. So you have two, one, two. There's an open one, but these are together. One, two, right? But
Mm-hmm.
like these guys are with the if statement. Does that kind of make sense?
Okay, got you.
And then this next one, else, this guy and this guy go with the else.
Oh, okay. Okay, now I see it.
And how you read it is like this. It's like how like this is kind of like a parentheses. It's kind of like a parentheses, right?
Mm-hmm.
This is like an open curly brace, and this is like a closing curly brace.
Mm-hmm.
And so inside it is what you run if the if statement is correct, and whatever is inside this else statement is what runs if nothing else is true. Okay, so do you understand if else now? The if else is not as bad as loops, but I want you to get this one because this will help you in the long run. Like all of these like basic code structures,
Mm-hmm.
they're just gonna get more complicated and get used like in a more practical way. But like right now we're talking about like what they are and how they're used.
Okay.
Okay, let's talk about else if now. So with an else if, let me just do something like maybe right here, else if, and then in the bottom here I'll do else, but then this one needs a condition. So the condition here, let's see, like maybe like let's make this true. 2 is greater than 1. And then for this guy, let's see, print. It doesn't matter what you print here. Let's do something different. Like, there you go. All right. So now I added this guy, right? I added this guy right here.
Mm-hmm.
And then so we said that this statement, because of the condition, it's not going to run, right? 1 is not greater than 2, right? But and then now what about this guy? Is 2 greater than 1?
Yes.
Okay. These are just examples. It doesn't matter. So if this guy is greater, if this 2 is greater than this guy 1, then now we know that this else if is gonna run, right? Because it's true.
Yes.
So usually how they check this is it goes with if first, it checks what if is. If that's like false, then it goes to else if. If that's true, it runs it. And let's see this. So let's run this now. So what ran? This guy ran, right?
Yeah.
And then so that makes sense. You know, you check if is it true, it runs this. If it's false, it runs else if. And it goes to else if, it checks else if. If this is true, it runs else if. If this is false, then it goes down here, it goes down to else. There's nothing to check in else. You just run it. It's only in the if and else if. That's another thing. Like there's, you know, if and else if you're comparing something. And then so when all those are false, that's the only time else runs. If any of these, if is true, it runs if. If else if is true, it runs this guy. But if is true, then it doesn't run this guy, right? It doesn't have to run this guy. It only, like for example, let's take a look at this guy right here. 2 is greater than 1. I'll make it the same, and then let's run it. So what happened here? So like I said, it goes from if all the way down to else, right?
Mm-hmm.
It goes from if all the way down to else. So it does this. So if 2 is greater than 1, I'm gonna run this guy, right?
Mm-hmm.
That's the thing that came out right here. But what about this guy? This one's true too, right? Isn't this guy true? Right?
Yes. Mm-hmm.
But it didn't run it. It only ran this guy. And then the reasoning for that is because it's not inside the curly brace of if. This is the whole if statement right here. This is the whole if statement. If you're not inside the curly braces,
Mm-hmm.
this open curly brace, closing curly brace, if you're not inside this guy, and this is true, like if this is true, it will run it, whatever's inside only. It doesn't matter what's after that. It will only run the lines after if this guy is false. So like, you know, 1 is less than 2.
Oh, so like an alternative, like okay, so if I say 1 is greater than 2, which is false, then the next step is the else if line.
Yes, you're right. Yeah,
It's going to
that's
run.
exactly right. Yes.
But if I say 1 is less than 2, which is, 1 is greater than 2, which is false,
Okay.
then it's not gonna run that line, it will skip to else if.
Yes. Yeah. Exactly. Yeah. That's how I look at it. Like you're just comparing this guy. If it's false, it runs else if. And what if this one's false? What happens?
Then we move to the third one, the else.
Yeah. So when you run this, you should get the last one, right? This else guy.
Mm-hmm.
And that's how you think about these things.
Okay.
It's just that basic, like, you know, loop, and it's kind of like a loop. It's a conditional flow is the basis of like if, else, and else. That's really what it is. And let's try to look at the switch statement. Okay, and let's see, switch. Let me see this on X, let's see this on X3. This would be a better one. This is not really that good. Okay, I guess you could use it that way. Or actually, no. Maybe let's not talk about switch. Switch is not really relevant here. Okay. Did you? So you guys talk about these guys, right? If, else, and else. Does it kind of make
Yeah,
sense?
yeah. Now it makes sense because I didn't understand it.
Okay. What about loops? Did you guys talk about for loops and while loops and repeat loops?
Yeah, he talked about loops.
Okay. There's a while loop and a for loop this side. Okay. Did did he talk about repeat? The typical ones are for and while. It's like
Yeah, he said those things.
okay. Do you understand like what any of these guys?
No, I
Okay.
understand none.
Okay. Let's talk about the one like each one of them. So let's talk about repeat first. So when you do repeat, what you typically do is like okay. For let's step back. A loop is like first of all, it is what it is. Like it, if you wanted to like write or execute or run a command, and you don't want to keep on writing the same thing every single line, then a loop would be the one that you should do because then you only have to write it once, but then you have to code the loop so that it runs like maybe 5 times, 6 times, as many times as you want. That's when a loop is used. Is when you want to repeat like a command or a code, maybe through like that. This is actually, I think I don't know if I did a loop. I did a function.
What
Um,
is a command?
a command is like any of these guys. Like print is a command.
Or the
Print,
ones in the parentheses?
yeah, any of
Okay,
those are commands. So
okay.
I want to run those guys, and then I don't want to keep on writing them because that would take forever, like 100 times. You don't want to do that.
Mm-hmm.
You just use a loop. And it gets more complicated than that, but that is the essence of it. So let's talk about repeat. Repeat, let me just write this one first. So, for example, you have, let's see, let's use V again. And this is what they're using. Let's put like some strings inside. So this is a string of, a list of strings, which has hello and then loop in there. And then this next one is, I don't like the way they're naming these. So I'm just going to put in like V list, not V list, and then count list. Variable. There you go. Let's just use variable. Next thing here is let's make this 2, and then let's write the actual loop. So you know what a keyword is? Did you talk about what keywords are?
Which one?
Keywords, keywords.
No.
Like this guy, like you know how this is blue. These guys are blue, right?
Yes.
And this guy is also blue. Like this
Yes.
repeat. So on the script, when things are blue, that means that they're keywords. So like I can't.
Oh.
That means keywords means there's a special use of that word. It's probably used like as a like a built-in function for R. Anything that's black or that's just like a variable or it's not a keyword. It's not important. So okay, let's try to write this repeat statement. So that, we have our curly braces. So now inside the curly brace, what do I want to write? Let me write like print v or variable list, and then in there I want to say the count of my just a counter. In there I want to put count 0+1 because I'll explain this after I write it. So counter +1, and then in there you want to put in an if statement. So let's put in an if statement.
Mm-hmm.
Our curly braces are conditional inside. So our conditional or our if statement is I want to see if the counter is greater than 5. So that's my condition. So inside my if statement, what do I want to write? So for my if statement, I want to say, I want to break this. So I think let's run that first and I'll explain it. Oh, that's fine. There you go. There you go. All right. So if you take a look at this guy, the way you write like a repeat, let me just put in repeat. The way you usually write these guys is you have to have like you have to define like the variable like a list first or whatever you want to print, because this is what we want to do. We want to print a few of these like strings as many times as we want, and so that's what you want to define first. You want to define like maybe a list or like a variable. So that's what I want to do, and then that's what you want to act your loop on. And then how you know how many times you have to run this guy is depending on like how many times this loop runs. I gotta say, like this is probably like the most complicated thing, understanding a loop. So let me know if something seems confusing.
So then, since you are saying how many times you run the loop,
Yeah,
is that why you have put in line 39?
this guy.
Yeah, does that have to do with it, like the 5 thing, meaning you want to run it
Yes.
5 times?
Yeah. Yep. So there's like two components. So you know why the reason how we know how many times this runs or how we like block like a loop from repeating,
Mm-hmm.
how we stop a loop, because it's a loop. It's just gonna loop to until there's like an ending, and the ending there is because of these two things. So the first thing is you need to define a counter. So the counter tells you to like it's like a flag. It's like your index. And then this counter, if you look over here, I initialize it. It's 2 first. And then so this counter goes in this guy. And then it says 2 plus 1, right? 2 plus 1, right?
Mm-hmm.
And then so now the counter, it began with 2, and now it's 3, right? The first time it runs. So it was 2, it goes here. It does this like, this expression. So counter plus 1 equal, which is 2 plus 1. Now
Mm-hmm.
counter is 3, right?
Mm-hmm.
So now the first time it runs, it's 3, and then it goes to this guy. So like I've already printed this. So the first thing is the first time it runs, it already prints this guy, right?
Mm-hmm.
And then so now counter is 3. Then I go to this guy. Is 3 greater than 5? It's false,
No,
right?
it's
So it doesn't run this one, right? It doesn't run this guy. So since that's false, it just goes back. Like so this is false, it goes back, and it doesn't even run this. So now I run it second time. So I get this guy, right? And then let me just change this. So like for example, what if I wanted this to equal like 3? And this is the one where I want to only run it once, because then it's just gonna do the same once. So it only ran once, right?
mm-hmm.
And then the reason why is because like so this is 2 first, it goes here, 2 plus 1, and then this already ran, so that's the reason why you have this. And then so when this 2 goes here, this is 3, right?
Mm-hmm.
And then so after that it goes to this if statement. So the 3 here, which is this guy, after you add like 1 to this guy, it checks is 3 equal 3? Is 3 equivalent to 3? Yes, right?
Yes. Mm-hmm.
So then it runs it. And then this is the reason why we have break here. So what happens with break is it breaks the loop, it ends the loop. So that's why we don't run it anymore, we only ran once. Let me say that again. Let me change this in like
So do
this.
you say you run it once or you run it 3 times?
You're running it only once and it breaks. But it depends on your your condition right here. So this time I changed my condition, right? This time I changed it to 4. It was 3. So this time it only ran like what, twice, right? So it was 3 before, and then like this, the whole reason why loops are so complicated is like this thing that we're talking about. Like you have to really dive deeply into like the each individual like cycle of the loop and really understand what's happening with this counter, and then why you're getting, you know, like 2 runs, 3 runs. That's the reason why, because they have to really like count how many
So
times.
let me ask you then.
Okay.
Okay, so based on what I'm seeing on the console window and what is on the source screen,
Yeah.
so when you say counter less than 2
Less than 2, where?
on line 34,
Yeah.
so
This
that
one,
means,
this one's assigning, this is assigning 2 to counter.
okay, so yes, so you say 2, so I was expecting that when you run it, I will see 2 lines in the console window.
There's 2 lines here, right?
Yes, and then if I move to step to line 37,
Okay.
where you say counter +1,
Yeah.
the way I understand it is that you're saying 2 + 1, so
Yep.
run it 3 times, but I'm not seeing 3 lines in the console.
I see. I see. It's not that way. Let me try to explain it better. It's really complicated. Like, so, you know, when you're outside the loop, this is the loop starts with repeat, right?
Yes.
This counter right here, this is not telling you like run it twice. It's pretty much telling you like I just have like this counter. This could be a flag. Like I'm just saying that I want counter to equal to. This is what, you know, this guy is saying. I want counter to be 2 right here. And then now let's do the loop. This can, and then so when you do the loop first time, you run this guy, right?
Right.
Okay. So and when after it prints, it goes to this, evaluates this. So let's see what happens with counter. Counter is gonna change inside the loop. It started with 2, right? This is the hardest part. It starts with 2, but it changes 1 once you go with the loop. Like once it's inside the loop, counter is gonna change. Like this began with 2, but now we're inside the loop. It's gonna increase. Does that kind of make sense? That's the reason why it's like a counter. And then once it counts, that's how you know that you have, you know, like it began with 2, and then it counts it, like, and then it increases it, and then we have to put in an if statement. This if statement is gonna tell us how many times this is gonna run. Does let me say that again. So you have this counter 2, right? And then now I want to increase that counter every time I run the loop. So I run it the first time, I get this, you know, I run this print statement once. Does that make sense? It runs it once.
Yes.
So that, you know, in along this line, counter is still 2, right? And then now let's go to this line. What's counter now?
So now it is add another one, so I get that to be 3.
Okay, now counter is 3. So keep that in mind. Counter is 3. Now I run this guy. What is this? So you put 3 here, right? And then
so then 3 is not equal to 4.
So does the if statement run?
No.
No. Okay. So if it doesn't run, it doesn't break. It doesn't run. It doesn't break because we have break here. Then it goes and does another loop, right? It does a second loop. Since you don't have this guy, it goes back up here. It goes back to this print statement. And you have this guy, right? So that's the second time it runs. So now let's see what counter is. So what was counter before? Like what did we end up? Like the first time we ran it, what was counter at the end?
The counter was 3.
It was 3. Okay. So we run it again, second time. And so since counter is 3, you know, at this point, at this line, the second time, Now we run this guy the second time. What is counter?
So that will be 3 plus 1 will be 4.
Yes. Okay, good, good, good. But this is what you have to think. Like, you can write this down if you want. Like, oh, this is how it does it. So now it's 4. Second time you run the repeat statement, or like repeat loop. So now let's take a look at this guy. And counter is 4. What happens?
If the counter is 4, which is not true.
It's this one's equals.
Okay, so that equals. So counter equals 4.
And that's true, right?
Yes.
Okay. Yeah, so like since the second time we ran it, counter became 4. And then we put counter in here now, and we check, is counter equivalent to 4? So does this one run?
Yes.
It ran, right?
Mhm.
Because counter is 4 now. And so what happens? Once you run the if statement, what happens to the loop?
So I think we will have more lines in the console window if you run it.
If we run this one,
Yeah.
you only have 2 lines. It's like,
Why are they only 2 and not 4?
it's only because of what we talked about. Like, so like when you run this guy, like this whole thing, you run it, right? The first time you have counter as 2, right? Let's change this guy so like it makes more sense. Let's make it 1, and then now let me make this 5, like maybe 10. Let's make it 10, yeah?
Okay.
Just to like mess around with like the example.
Okay.
And look, it ran many times. Let's count how many times it ran. 1, 2, 3, 4, 5, 6, 7, 8, 9. It ran 9 times.
9 times.
And how do you know? I mean, you can probably guess it because then you started with 1. But like, let's just do that. Like, I don't know, like it's really tough if we go a higher number. Let's just do 3. Maybe it's like easier to explain. I don't know, maybe like 4. Okay, good. Okay, I think it's easier to explain if we only do 3. So the first time, let's do this again. So the first time, outside the loop, what did we do here? We made counter equals 1, right?
Yes.
Okay, now let's do the loop. The first thing in the loop, it says print this thing. So this is the first time it runs, it prints this guy, right? Okay, what was counter before? It was 1. And now once we run this this statement right here, what is counter now?
Counter is now 1 plus 1.
Okay, so now counter is not 1. You added 1. It's going to be 2, right? So the first time it runs, counter is 2. So the first thing on there is going to be this guy. And then let's see. So when you do that, so it's 2. Let's check if this is true. Like, so when you put counter here, right? So does this if statement run?
No.
Okay, so that's right. This one doesn't run the first time. So we skip this, we go back and run it a second time. So the second time it prints this guy again. So we have this guy, right? So the second time it runs, we have this guy, these 2 guys. So let's check. So what was counter at the end of that? It was what?
So if we had 1 and now we run it a second time plus 1, so that's.
So like after the first loop, it was 2, right? Like after the first.
Yeah. We ran it the first time we run it was 2. So if we go back up and run it again,
Yeah. What is this
Yeah.
now?
So that's 3 right there.
Good. Okay. So we put 2 here plus 1. Now counter the second time the loop runs is 3. So now let's check the if statement. So 3 here, right? Is this
Mhm.
true?
No.
That's false. It skips it and it runs the third time. That's why there's 3 here now, right? There's 3 lines of this guy. So it runs the third time. Let's check what happens. So now you put 3 here, right?
Yes.
And then what is counter?
So if we run it a third time, the counter will be 3 plus 1, so that will be 4.
Okay, now this is the kicker. Now what about this? So now
So,
what happens
so,
with the if statement?
so then the if statement will be if now counter is 4 equals 4, then it is true.
And so if it runs, it breaks, right?
Yes, so it will run.
It will not run. It'll break it. Oh wait, yeah. This if statement is gonna run, but then this whole thing breaks, right?
Yes. Mhm.
So that means we don't have a fourth statement. Or we don't have a fourth line because like it only we only run it 3 times, right? 1, 2, 3. It breaks. This becomes 4.
It breaks on third run.
Yeah. Does that make sense? That's how you know how many times it runs by going through that. And it's all depending on where you started and then what is counter in the end. What do you
Okay.
think? What do you think of that one?
Okay, I think I is kind of getting in. Yeah. Mhm.
Okay.
So
Okay.
basically, counter if it doesn't run, then if you repeat, then that increases the counter number.
Yes. If you repeat, it increases the counter number. It's up to you though. You can make this like you can make it increasing. Right now, yeah. Just think about that. Yeah. The reason why it increases is because you added 1 here, right?
Yes, because of that one.
Yeah. You could have made it like this guy maybe -4, right? This guy right here.
Mm-hmm.
And instead of increasing, you want it to decrease, right? Look at it. Like it's different now.
How come?
It's different because of what we changed.
Ah.
So like the first time we added 1 and we made this +4. We made this +4, right?
Mm-hmm.
You really can't tell how many times it runs unless you go and then not the second. Now I want to change it. I want to make the counter decrease. I want to make the counter decrease. So I'm gonna -1. So if I -1 and then maybe it's decreasing. You started with 1, right?
Mm-hmm.
Just we don't have to go through the process, but if it on your own time you can like go through like the process.
Mm-hmm.
But you started with 1, right? And then now I'm not increasing. I'm minusing 1. I'm subtracting 1 every time we run the loop, right?
Mm-hmm.
So the end goal is I want this to run until my counter is -4. So this is kind of like your end. Your start is this guy, and then this is your end,
Oh, okay.
and then this is your incrementer. This is how many times you increment it. You increment it 1. So you have 3 things. You have the where you start, where you end, and then where you increment. You're minusing 1. You're minusing 1 every time you loop it. So when you run this, it's different, right?
Mm-hmm.
So like it's just really like like going through those steps, and maybe if you change like this guy, you change this guy, and then this guy, and then go through those steps like maybe 5 times, you're gonna get it. And like usually what I do is I create a table. It says like what is counter, what is it after the first time it runs, and then so what is counter again the second time, and then what is counter again the third time, and then like you just check, okay, when counter reaches -4, when counter reaches 4, how many times did I run the loop? And that's like the mindset. That's like the what you have to think about. Okay, so that's repeat. Let's talk about while loops. This is another one that's like really complicated, but it's kind of like it's in the same realm. It's the same as like the repeat loop. So let's just use those same guys. You know, same example, but then using while loop. So let's do the while loop now. While, and then let's put in maybe like the counter. You know, the same kind of like example. The counter here equals like, let's say equals 4. And then so when you do that, then I want you to print the list, and then the counter, I want it to. Okay, do you see the sun?
Mhm.
Hold on, let me see this. Counter equals 1. That's weird. How come it's not printing? Counter. It's 1. Oh, it's not.
So when you start to print, do you just put it on line 47 or 47 and 48?
For this guy?
Yeah. Oh, that's where you put your cursor. Okay.
Yeah. Let me just see first. Because this is supposed to. It's less than that. Okay. There you go. That makes more sense. All right. So let's. How many times did we print this other guy? So let me just check how many times we printed. How did it do that? Okay. So when you print this, you get 3. When you print this, you get 4. I want it to be the same. So let's print it 3 times. Okay. It runs now. Okay. So for the while loop, it's going to be kind of similar. Like we started with the same guys, you know, the var list, hello, and loop, and then you know this counter here right here is going to be the same, right? Let's talk about the same thing so it's consistent. So you have counter, you start with 1, right?
Mm-hmm.
And now we're not using a repeat loop. We're doing the same exact thing. All of these guys can do the same thing. It's just different syntax. So if you remember the repeat loop,
Mm-hmm.
the repeat loop didn't have a condition here, right? But the while loop has. So like if you do this and there's a condition, the first time it runs, it's gonna check while the counter is less than 4. So while the counter is less than 4, what does that do? What is that? Is you start with 1. Is this true or false?
While my counter is less than 4,
That's false, right?
and that is false because my counter is 1.
Yeah. So a while loop, what ends up happening with a while loop is you always check if it runs if it's false until you get until this is not true, and you know, well, counter is less than 4, it runs it if it's true until it's false. There you go then. So 1 is less than 4, right?
Mm-hmm.
It's true. It's gonna run it until you hit a false. So in this other one, the repeat, we didn't have a condition. That's why we have this if statement here, right? To break it, right?
Mm-hmm.
But then for a while loop, it's even cleaner. You don't have to write so many lines because the condition is part of the while loop, the while statement. So instead of doing like an if statement, we did a while statement right here, right? So the counter starts with 1, and then it goes here, and it's true. So while 1 is less than 4, which is true, run my while loop. So it runs this guy. This is the first one right here, right? And then what's your counter the first time it runs?
So the first time it runs, you add 1.
So what is counter now?
So let's see here. Counter is 1. While counter is less than 4. So it will be 2.
It's 2, right? So the first time it runs, counter becomes 2. It started with 1. You check the while loop condition, which is true. You run it. This is true. So you have the first print statement here. And then now you want to increase counter the first time it runs. So now it's 2. So then you run it again, right?
Mm-hmm.
You run it again. So what is that? So 2 is less than 4. That's true, right?
Yes.
It runs again second time. It prints the second time. That's this guy, right?
Mm-hmm.
And then now what do? You increase counter again. So it runs the second time. It started with 2. Now what is it?
So now it increases to 3.
Now it's 3. Okay. And then now you go back. You go back to this guy, right? You go back. So you check. While 3 is less than 4. That's still true, right?
Yes.
And then it runs the third time. So then you get this guy. Now you have 3 lines altogether. 3. So it runs a third time. And then now you go here, you increase counter again. What is counter? The third time it runs.
So that brings it to 4.
You're at 4. Okay. And that's the kicker. Now it's 4, right? And then you go back to this guy. So what happens? 4 is less than 4. Is that true?
No, so that's false now. Oh,
So,
yeah, the third one. Mm-hmm.
so you check it, and then since it's false, it doesn't run, right? It doesn't run. So that's why you only see 3 here. The fourth time you check it, like, third, it became 4. Fourth time, you're anticipating it works, but you check the while loop, it's actually less than 4. So it doesn't run the fourth time. It only ran 3 times. Kind of similar to this guy. It ran 3 times. That one's a little easy, right? The while loop.
Yeah, the while is easier than the other one. Is a little complicated.
The reason why I wanted to go through all 3 of them, there's 3 of them, is because they exist, and supposedly they all should give you the same thing. You can do one thing with a repeat loop. You can do the same thing with a while loop. Okay, so you understand the while loop. Let's talk about the last one, which is the for loop. So the for loop isn't that bad. It's the one that's used most. It's actually the one that's used most. So let me just write the counterpart for this one. Barless. Just copy this. And after this, I want to explain, since we're almost done, I want to explain week 5 after this one.
Okay.
So for, and let me run this like maybe, you don't actually need a counter for this one. So the counter for a while loop is inside already. Counter in var list. And let's do this. Okay, counter. Nah, this is not written the way I want it to, so. Let me think about this one. Counter. Okay. You run this counter equals counter plus 1. don't think this is gonna run. Let me just see. Okay, it did run. That's good. So 1 plus 1. You only run twice.
May I ask something?
Okay, go ahead.
At the bottom, on line 58, I understand that brace, but I don't understand why there's a brace on line 59.
This one is for the for loop.
Oh, okay.
Yeah. Usually for the for loop. For the for loop, it's a little bit like if you're trying to run it. Because I need a range here. I need a range. Let me see if I can define that one somewhere. It's been a while. For range in R. There's like different ways you can run this guy. Oh, okay, maybe this is on. There you go. Maybe that's on. This one, I want to run this like 4 times. I want to run this 4 times. So it has to be 0, 1, 2, 3, 4. Okay. Okay, that makes more sense. Yeah. And then if you do it with 2. Okay, there you go. That's the equivalent. Try like to find different ways that you can run this. So you guys talked about for loops. The way I would typically do this here, let's just change this to counter because that's pretty much what it is. It's pretty much the counter, the one that's inside. Instead of this guy is still gonna be the same, right? We still have the var list. We want to compare, and then like now we're running a for loop instead of like a while loop. So like the way we had the while loop is kind of similar. For loops and while loops are very, the way the syntax works is very similar. You have a condition here. You have like this guy here, right? This is a condition, while loop statement. For the repeat, it's different because there's nothing here, right? So the way you look at this though, it's a little different from the while loop. Let me try to explain that. So what's in here is you have this counter, kind of similar to the counter we had here.
Mm-hmm.
And then this counter kind of like takes in like different numbers every time you run the loop. We've known that run, right? Like that's the one that always changes. And it's like an index.
Counter changes every time you repeat, it adds 1. Second one, third one.
Yeah.
So the number would increase by the number of times
you run the loop. Yep.
You run the loop.
That's exactly, yeah, that's correct. So for all of these, they all increase. It just depends on like how it increases. Like that's the change, that's like the difference between repeat, while, and for. For the for loop, the while and repeat are kind of similar. You have to do this counter right here, right? Counter plus 1. And then right here, counter plus 1, right?
Mm-hmm.
And then you initialize the counter for the repeat and the while loop. You initialize the counter. For the for loop, it's all of that is like simplified. Like pretty much like the way and it's different. You can see it as different or simplified. And if you look at it, you can run all of that. This one was the longest one. This one's slightly long. And this one's the shortest one, right? It's only 4 lines. So go ahead.
So does it mean for the for loop, you just run it once?
No, okay, let me clarify that one. So you're actually running this the same amount of times. We ran it 3 times. Let me explain.
Where is my command in counter to run it a couple times?
Okay, I'll unpack that one. So the reason why this runs 3 times, let's go through the process again, of like increasing the counter and how many times we go through the loop.
Mm-hmm.
So the first time, you go through this guy, the way this is working is counter in. This is a membership. like it's saying like, you know, when you have in here, it's like a membership. It takes in. So on the left is what you're gonna. It's like a variable, same as this guy.
Mm-hmm.
This one, it's putting 1 to counter. This one here, you have. Do you remember what this is? This is a range, right? Like
Oh.
if you print this guy, like I'm just printing that guy. I got
Mhm.
0. You know what is 0:2? What does that mean? It's this guy, right? 0, 1, 2. It's a
1 to 2.
collection. It's a list, right?
Mm.
So 0, 1, 2 is a list. So then this is how you define it. 0:2, and it prints 0, 1, 2. That's what it is. So within this list, the first time it runs, counter gets 0. The first time it runs. Does that make sense? Like the first time it runs, I'll just put in a comment here. Is like counter.
Oh, so it starts from 0.
Yeah. It
In
gets,
this case.
in this case, you don't have to make it start from 0. You can make it start from 1.
Okay.
Like,
Then if I start from 1 to, if it's 1 to 3, then each time I run, it starts running from 1. So the second time will be 2, and then 3.
yeah, you got it. So this one you know the for loops. The for loops are pretty easy.
Ah, okay.
That's how you do it. Yeah. For the counter, it goes to the series here, the
The range.
sequence, the collection,
Mhm.
and then it runs it. It goes to the next one, and then it runs it. It goes to the next one until you're done. Which is 3 right here, right? It's easy to see because the 3 is right here.
Yeah, because this one, you even see how many times you need to run and where to start.
Yeah, exactly. It starts at 1 and it ends at 3, right? It starts at 1 and it ends at 3, and then you know it's gonna run 3 times because there's only 3 things here.
It's because you only 3. This
Yeah,
one is better. Mhm.
exactly. You should just use this one forever, you know? I know. But the thing is, there are times you want to do. It's more flexible to do these other ones.
Yeah.
But there's you always want to see what's the different options that's given. Okay.
Yes, yeah, because situations might also be different that needs you to use a particular formula.
Yes, exactly. Okay. I think with the time we have, you want to talk about the week 5.
Okay, yeah.
Some of these, let me see. So like, maybe which ones do you feel like we should talk about more? Do you know how to do this one?
Yes.
Okay, that one's good. Okay. And then what about this guy? Like, there's some bunch of words here, but this guy, this one's easy. Like, I think it's given to you. Do you know what this is doing?
Yeah, that read CSV thing. So it's pretty much about this file that you got from GitHub,
Yeah.
and this is the location. The read underscore CSV is the location where you got it. You pull
And then
it from.
it pretty much puts it into a data frame, right? This is the data frame.
Okay, so the data frame. Okay.
So like you start out with a CSV, and then when you do this command read CSV, then it becomes a data frame, right?
Wait, I was understanding that the read underscore CSV is the data frame.
Then read CSV, this guy right here.
Yeah.
Yeah. So what this is doing is it's taking a CSV, a comma separated value or spreadsheet, whatever. Then it reads that and it makes it into a data frame. This is just a command. This is a command right here.
Okay, yeah. So the read v is a command.
Yeah. And
In
then this
CSV.
this is pretty much saying I have a data frame called PED now. It's a variable data frame. It's a variable for the data.
Okay. PDE is the data frame.
Yeah, whatever you put here, it doesn't have to be anything. Like it could be like DF data frame. But
Something.
what this whole thing is saying is I want to get a spreadsheet, a CSV file, and then I want to convert that to a data frame.
Okay.
Yeah. And then let me see if you can actually. see that. There's like ways that you can visualize this, that data frame. Because like, you know, you want to always be working with like a lot of the times like you pre-process something.
Mm.
That's when you get like all these databases. CSV is a type of. There's also like a XLSX. There's like, you know, that a lot of databases. And like when you're trying to, let me see if you can actually get this on data that. Let me see if this one works. Let's see. I have to run this one first. Okay. Then this one. Okay, it reads it. That's good. Okay, so that one's good. It reads it. Okay, so now you have your data frame. Let's try to summarize the statistics. This is the part like I wanted to get to this. We'll talk about it more later. I think it's better to you know, like you know what, while we did the demo here,
Mm-hmm.
like I wanted to get to the statistics.
Mm-hmm. Right.
We'll do that later because like that's like I want to really get the basics out there for coding and then
Yeah.
actually embed it into like something because then it makes the whole thing holistic. Like you know the theory and then now you want to apply it to statistics.
Mm-hmm.
So like I'll just talk about it here, but then like we'll dive deeply to it like later, like each individual, like what are you doing here kind of deal. But so this one's asking you to do some statistics, right?
Mm-hmm.
And then how I usually do that is like you can just do summary. Summary is a command. And then your data frame. You do summary and then inside you put your data frame, PED. So when you run this one, you get this guy. You get like a summary.
Mm-hmm.
Does this one make sense? I don't know if these are something things that you guys
Yes.
talked about already. Okay.
Mm-hmm.
And then so you have the summary, and then so you get like the minimum value, the median, the mean, the max, and then like the the first, and then the middle value, and then the third quartile. You get all those guys, and then the max is like the fourth quartile. And then like other things you can do is maybe get the mean of the the just an individual mean instead of like the summary. And then I want to put that into like because you want to be graphing this guy. Like besides getting like a statistic,
Mm-hmm.
you need to graph it. Sure, right? It says here graph the distribution. Does that one does what did your professor say about that one though? Like what does it mean to graph it? Like what
He, let me see
histogram
here.
or like this is what I'm thinking he wants. He wants the distribution. What did he want for that one? I was a little because it could be histogram or
I think uh, I don't see the. Let me check. Give me once here,
okay.
just to be sure.
Because it could just be this guy. Another command we can do is like we can just plot the pedestrian like this guy. You know, you see this guy right here? It's pretty much the same thing. Like if I were to plot like this guy, I think it's a little too close. Let me just make this. There you go. Because you could either make a histogram or you can make this guy, which is like similar.
Okay, I think the other graph, that one.
It's the same thing though, if you look at it.
Oh,
Right?
it's the same thing.
Yeah, look at it. Like it's you have this one going this way, and you have this guy. It's your normal distribution.
Okay.
But this one just goes with like the actual numbers that you have. This one you have to do more things because you have to figure out like the mean and the standard deviation. Did you guys talk about standard deviation and mean?
Yes.
Okay. And then you need those two variables. Did he talk about mu and sigma?
Yes.
Okay. So mu is mean, sigma is standard deviation. And then you need those two numbers in order for you to create this graph, the normal distribution.
Okay.
But then you could just use the data frame. This is pretty much your data frame graphed as a histogram. The pedestrian distribution, the pedestrians. Does that like okay? So that's what you're doing here. You have to like do the statistics in numbers. I have it right here in numbers. And then I'm just gonna include like these two. I guess it's good to have both of them. And then you have the normal curve distribution of the pedestrian. And then you have the histogram. Is that what he wants? I think that's what he wants.
Yeah, that's what he wants.
Okay. Does that make sense though? Like how you do this one, the code here?
Yeah, that's the fact that I'm not sure.
Okay, let's explain it.
Yeah, if we can go over that.
Okay, so the first one here, PED, this is the data frame, right? PED is your data frame.
Yeah. Mm-hmm.
So you have, I'm trying to remember how you, I want to include, let me see if I can do that. I want to see what's inside this guy first. It's if you do like maybe print dot data. Let's see if that. Okay, that's not the one. Oh, I think I know. Actually, hold on. Here we go. This is the one I want. So we create a data frame from the CSV file, and this is what we have, right?
Mm-hmm.
Let's see if I can get more. Oh, doesn't even know. Okay, whatever. Oops. Okay, so you see, like this is the data frame. You have like a bunch of pedestrians, and that's what that is. And and this is a really easy data frame. It's only like one column. So if you were to, create the stats for these, all you have to do is like do summary. So that one, does that one make sense? The summary is just pretty much a command. Does that one make sense?
Mm-hmm. Yeah.
Okay. And then like, if you were to create, ignore these other guys, ignore these guys. I just want to show you how you do this one right here. So this one's the easiest one. All you have to do is hist, H-I-S-T. And when you do that, you understand this guy, PED $ pedestrians. Like this is when you do this, like you know that the data frame is PED.
Yes.
But then you need to tell the computer, oh, I want you to graph pedestrians. So how you do that is you have to put in this $, and then the name of the column, which is this guy, pedestrians. And that's why I wanted to print this out. You have to print this guy out so that you know what's going on. The pedestrians is the column name, right? right?
Mm-hmm.
So, you know, if you did that, you get this PED $ pedestrians. I want to create a histogram of the pedestrian column. And then, you know, this other part is just saying I want to create like a name. This is not important. This next part right here is not important. You can just do this. This is all you need, the histogram of the, that's the easy one, right? Like summary and histogram is easy, right? You just have to know what these are. You have to do summary of PED and then the his of the pedestrians, PED pedestrians. Those two things make sense. I'll explain the third one, which is like more complicated. Does that one make sense? This one?
Yeah, so that one I understand. So you want a graph, so you have to print the
Yes.
data frame to give the graph of
The data frame, yeah.
the data frame.
And then how you do that is you just type in hist, HIST, and then PED, the data frame, $, and then the column name. The column name is pedestrians. Does that one make sense? That's the syntax of how you do these things. Like,
That part makes sense.
yeah, okay. Okay, so that's good. I think, let me see if you can even do that. But I think you could do this one. So let me see if you can. Oh, so you could do that. You gotta do that, or if you want to just do the data frame, you could do that as well. Do you see what I did there? So for the summary, you could either just put in the data frame or the column of the data frame, which is like this guy. It gives you the same thing. It's just different, like display.
Okay, so which one did you use for this one?
Summary.
So the summary, you can use the summary in two different ways.
In essence, yeah. You can use summary in two different ways. So one way is just type in the data frame variable, PED, which is what we have now, or $, and then the column name. It still gives you this guy.
Oh, it's just arranged. Okay, so it's just arranged differently.
Yeah.
If you do it that way.
But for the histogram, you have to put in the PED $,
For histogram.
and then the column name. Because you don't, this one gives you an easy one. The reason why we do that is this one gives you one column, but then sometimes there's multiple columns. You know, there's multiple columns, so that's why you do this $ thing. For me, all I would remember is this $. You have to do this every time.
Okay.
Frame, $, and then the column name. That's what you put inside these guys so that you can like do some math or do some statistics. Okay, let me try to explain the third one. The third one's really difficult. It's not difficult, but like the coding. You know, this guy. Okay, let me try explaining this guy. So like when you take a look at this guy, uh, I would look at doing this first. So you know, you can do mean, right? Mean is another one. Mu is mean, right? Mu is just another word, a variable for mean, right?
Yes.
But I would just type in mu and then make that equal. Make it equal this guy. So mu equals mean of. You don't even have to like. For me, maybe let's not do equal because that one makes things complicated. But no one really does that one, and you can just do this. There you go. It makes. Okay, so mean, and then do this arrow thing, and then to the like subtraction, and then so this one, you do mean, and then what you put inside is the same thing. The name of the data frame, the $, and then the column name, pedestrians.
Mm-hmm.
And then for sigma standard deviation, the code for that is SD. So sigma standard deviation, the code for it is SD. So sigma is your variable. You make it equal. SD, the command, and then whatever you put inside SD is the, the data frame name, the $sign, and then the column name. Those two make sense. Does that one make sense?
Mm-hmm.
Okay. Now let's talk about the range. So the range can be like, I can make this as big or as wide as I want. Which is like, I think for me, I like it to be 4. This one's a little bit complicated, but let me just explain why I'm doing that. Okay, so for the range right here is like the bottom guy right here, right? This is like your pedestrian's frequency, whatever, or not frequency, but then the value of it. That's your the value of your pedestrian, per hour, I think. For this one, right? It's this guy right here, right? The pedestrian. The one that you have at the bottom right here is like your pedestrians. But how we're graphing it is kind of similar to the histogram. Like the histogram right here.
Mm-hmm.
Also, the range is the same thing. Is how you would go ahead and do that is you have to do sequence SEQ. So you do this guy SEQ,
Mm-hmm.
and then in the SEQ, what you put inside are here. The first one, there's 3 things you put inside. The first thing is you put in your mean, your mu, right? Minus, this is like the beginning. That's like, this is like your range. Your range is from this guy, right? From the left to the right, right?
Mm-hmm.
And then in the middle here, what is in the middle? This is your mu, right? Your mean.
Yes, that's my mean.
Your mean, and then you go to the left, what do? You minus what? Sigma. Right? Mu minus sigma is everything to the left, right?
Mm-hmm.
And to the right is plus sigma, plus standard deviation. Either 1, standard deviation, 2, 3, 4, whatever, So this is what I'm doing here. I have mu, which is the mean in the middle, and then I want to create the range, which is what this is. And then how you do that is with the SEQ, which is a command that tells you, that takes 3 things. The first thing here is mu, the mean minus the 4. 4 is just how far I want to go, from this guy. So this is where I start, minus 4 sigma. Does that one make sense? Sorry, it's a little blurry.
That makes sense.
Okay. And then the next thing is like the maximum value. So this is mu, right? Let me just make this smaller so I don't have to keep on scrolling up. So this next one here is mu plus 4 sigma, right? So that's the maximum value. So the maximum value is this guy. So how do I get to this guy? You have mu plus 4 sigma, right? Mu plus 4, which is this guy. The reason why I made that 4, it could have been like, if I make it 1, it's going to be really short. It's not going to tell you everything. See, like it's going from here. Look at it. Right? It's like going, you're not seeing the maximum value right here. What is the maximum value? The maximum value is 132. You're not seeing 132, right? In this guy. It's only 115 or whatever, a little bit bigger than 115. So that's why I wanted it to be like 4, which like defines like a wider range. It gives me a wider range. Does that one make sense why I times it by 4 sigma?
Mm-hmm.
Because then like I wanted a wider range. Because if I put like 3, like, the way I would do this is like see if 1 works, 2 works, and then, if you put 3, does 3 work? And this can work a little bit. What was your minimum? Your minimum was 77, and then your maximum is 132. So this can work, right? Maybe it doesn't have to be 4, but 3. 77 is right here. And then your maximum is 132, right? 132 is right here. So this one can work, right?
Yes.
The reason why I say that is I want to, you know, I want to fit all the data in my range. So that's why I wanted to make it 3 or 4. And then this last part right here is just how many times I want to increment these guys. Like I want to see how many times I want to increment them. I mean, I guess you could print out what they are. We could say, what is the range? So this is what I'm doing right here. This is what I have. This is actually the range. You see this?
Mm.
So like, remember like what I graph? The graph is this guy, right? This guy's the graph, right?
Mm-hmm.
And then the range at the bottom that I have them going from mu minus 3 sigma to mu plus 3 sigma in increments of like 0.01. It's this guy. See, it's going from 0.01. You can see it, right? There's like so many things.
Yes, it's so many, like even how to go to our range.
62. You can make this as like as little as you want. You can make it 0.1. You can make it 0.1, and then maybe it's not as much. This one's going 144. This one actually like that. That's the reason why I put the range there, because the range itself is like what you're graphing. Oops. The range itself is what you're graphing. In here. All right, so you have the mu, you have the sigma, you have the range. The reason why I wanted to define that is because of this D norm. And then this D norm, this is what you're graphing in this guy, this Y right here, is like the normal distribution. He talked about the normal distribution, right?
Yes.
So you have the normal distribution, and then, yes, that's what it is, but then how do you code that in R? How do you code it in R? You use D norm. D norm is like the command for it. So this D norm takes in the first argument, the first guy is range. And the second argument, the second guy is mu, or mean. And the third argument is sigma, or standard deviation. That's the reason why we wanted to calculate those 3 things. Because we need to define what Y is in order to graph the normal distribution. So like after you do that, then you just do plot, and this is what you get. Let me see what let me do that, and let me see what's inside Y. Let's look at what's inside Y. So this is what's inside Y. So just to, I mean, like what I'm trying to do here is I'm just trying to show you what's being graphed. So you know how like we have range here, and then Y. This is range, right? Then you have Y right here, and then Y is like the normal distribution, right? So you need to be able to get this in this guy. So the range, we already got it. Range is just all your pedestrian values, right? And then like and that's just like so that you have the same amount of so you can graph it. And then Y is your normal distribution, like the equation. If you put it in that equation, this equation here, normal. Like you could have done this in paper if you wanted to, but like, do you remember this equation? This guy, this one right here.
Yeah, but I never understood it, but I remember it.
Okay, no worries. Like, usually I never did too. It's the thing is, can you use it? So like there's this guy, right? And then there's also this guy, right?
Mm-hmm.
And these are the ones we're using, right? And this is the Y. This is the Y. This is the Y. If you take a look at these guys, you have sigma,
Mm-hmm.
and you have mu, and then the Y is the normal. That you're actually just applying that guy. This is just applying it. This is the Y terms. You have sigma, you have mu, and sigma is here again, and then you just do this whole thing, and you get Y. And then so that's how you get Y, and then you just plot it. You have the range, and you have this. That equation is this guy.
Oh.
It is what it is. It's just plotting that equation.
So that's the Y, the denom equation.
Yeah, the denom equation is the
Is
Y.
the Y.
Yeah.
And that's the graph.
And the graph is the graph of this equation.
And that's the equation used to get the graph.
Yeah,
for the Y.
But this equation is denom. That equation is programmed in denom.
Oh, okay.
This
Thanks
equation
for
is.
saying this because this is like.
I know. No, like this is why I like.
I really want to learn these things, Paul. I really want to I want to really learn these things. Whatever it will take, I want to get these things.
Yes, I'll do my best to do that.
I will not quit.
No, don't. Like this is like very fun because knowing this is very important because there's like an extension. Like what is the goal of this class? Like it's gonna teach you everything in data science or in statistics.
Yeah. So the goal of this particular class is data analysis and statistics, and the goal of the program is business analytics.
Business analytics. Yeah. Yeah, you can apply this so much. Data science and business, and then there's a lot of
so
statistics.
I can work in any industry.
Yes, that's why I wanna work with you, like with teaching you all these different. The teacher is probably really quick. That's why, like the class is really quick, right?
It's really quick, and I started late, and then I got lost. I didn't know where assignments were kept because it's an online class. So I didn't know you click under the weeks to find your not just the assignment, the lectures. He pre-records the lecture a week ahead of class. So you can go through the material, then when you meet, you have a question. I didn't know the lectures were somewhere there. So I was just struggling when I look at the assignment. I was going to Google, YouTube, and I've gone through a lot.
YouTube can help you, but then like it's always better because you can't ask questions. So yeah. So like I'm willing to work with you like as because the way we're gonna do this, how you can really understand the material.
Yes, that's the goal.
This class isn't just about like the theory. You have to understand R, right? Like R
that's
is like
that's what I want to learn.
Yeah, R is like the one thing that it's used in industry, but if it's not hard to learn, it's not hard to learn R. It's just what are like for example, what is this denom? Denorm, denorm. This denorm is just this equation. Those things have to be like, you have to know that. And then if we don't know that, then we can't really relate theory with.
Yeah, you can't relate because you need the two. You need the denom, and then if you understand R, if you put them together, you can get your graph.
Exactly, and then that's really the hardest part because knowing the equation. This is the theory of the statistics. Knowing the equation, it's easy. Yeah, I can just plot the points with my hand, but do you know how to use the code?
How to use it?
Yeah, the code here, and then that's like the hardest part. But I'm willing to tell you and go go the mile step by step.
Yeah, I'm gonna go.
Okay, let me just go over the rest of them. So this is it for this guy. Just to breeze through it. We can always do this again. We can go and like talk about this again for other times.
Yes.
What about this guy? Do you know about the hypotheses, the null hypothesis? Okay, I'll talk about it briefly. But like, let's say you have the like, what is the hypotheses here? Like what is like the let me rephrase that. What do you want to know? Like this? There's the situation right here, right? What is this one asking you?
It's asking me,
Like there's a scenario here.
okay, so he is trying to open a new franchise
Yeah, okay,
at a
good.
particular location in New Jersey.
Okay.
So he wants me to look at the information he is providing me
Yeah.
to help him determine if this is going to be a feasible project or not.
Yeah. Right? Okay. And then like what is the what is the task for the statistician? Like for you? Like what do you need to do?
So first I need to look at the variables that will determine if it's going to work or not.
Okay.
So he has given me some indicators like the number of pedestrians that pass there randomly each day,
Okay.
that kind of thing. So that's one of the features I'm looking at. He is also telling me like the location where he wants to start up the business.
Okay.
You know, how many people on average pass there per day, per hour, that kind of
This guy,
thing.
right? That so like I just wanna like the one thing that we wanna like look at is so this data is the number of pedestrians per hour, right?
Mm-hmm.
So the number of pedestrians per hour. And then like I think the most important like basis or like what we're trying to analyze is this guy right here. So that new franchise, he's only willing to open it if the number of pedestrians in average is more than 100, right?
Mm-hmm.
So that's the one piece of information that's gonna help us figure out what to test. Let me unpack that one. So what he's trying to say is I'm only willing to open it if I get more than 100 pedestrians per hour. So he's saying this is an average, right? This is an average, right?
Yes.
And then what do we have here? Mu. So knowing that the client is only wanting to open the franchise if he gets an average mu of greater than 100, that's what I want to test. I want to test if mu is greater than 100. And that goes in your null hypothesis. H naught. This is H0. Does that one make sense?
Yes. Mm-hmm.
But then now you have to test that against something, right?
Yes.
So like that something is gonna what is it is like the opposite of greater than 100, right?
Yes. So that would be the opposite of more than 100, would be less than 100.
So that's what I have here. The alternative hypothesis HA is mu is less than 100. So you have those two. You have to set that up, and then let me just like back out and say, hold up first. What do you know what alpha is?
No. Mm-mm.
So alpha is what we call confidence interval. So like our confidence interval. Here, let me see if I can define it better. So in statistics, usually the confidence interval that it gives you here, you usually assume 95%. Do you remember the thing about that? The confidence interval is 95%.
Yes. Mm-hmm. That's
Oh,
an assumption of 95%.
yeah, and then alpha is 1 minus your confidence interval. That's what I wanted to correct. So alpha right here, this guy,
Mm-hmm.
this is
Mm-hmm.
1 minus your confidence interval. And then this confidence interval is usually assumed as 95%. Confidence interval is usually like 0.95. And like this 95 just saying that like this is how much you're confident about the you know the data that you have. But then the alpha is the the likelihood. It's kind of like the likelihood that the population, you know, the data is outside the confidence interval. So this alpha right here this is your likelihood. It's kind of like your probability of that you're outside the confidence interval. And the confidence interval is saying like, I am 95% confident that the data and that my hypothesis here is correct. So that's technically the theory, but then what are you trying to analyze? Let me give you like the how first. So like what you're trying to analyze here is he's only willing to open it if the average is greater than 100, right? So you have to run a t-test. This t-test is a lot of things. Like it's you know, like for small data, and this is a small data. You only have like I think 10 things in there or 40. So when you run this t-test, and then let me just give you the ones you know, the results. So when you run this t-test, the only thing you have to look at is this p-value. Probability, I think it's like called probability value. So this p-value right here is what you have to compare to your alpha. So if you run it and your p-value is greater than your alpha, then you accept the null hypothesis. If this guy, the p-value is less than alpha, then you accept the alternative, or you reject the null and you accept the alternative. That's like how you have to analyze this. Does that one make sense?
Okay, so you're saying if the p-value, which is a 0.9412,
It's greater than the
greater
alpha.
than
0.05, yeah.
0.05,
Yeah, which it is.
which is, then I accept the
And you accept
alternative.
the null hypothesis, yeah.
So which is the null hypothesis that is mean is greater than 100.
Yeah, if it's less than alpha, then you accept the alternative, or you reject. When you reject the null, that's the same thing as accepting the alternative, right? Yeah, that's how you have to think about doing this type of analysis is you run a t-test.
And the alternative in this case would be the
The alternative here is it's less than 100, but what does that mean? He's not gonna open it. He's not gonna open the franchise. I think that's what he says.
okay.
Says there that he's gonna consider it, but then the only way he's gonna consider it if the site is acceptable only if the number is more than 100.
And it's not more than 100.
And in our case, if we accept the null hypothesis, then that means it's more than 100. If we reject it, and we accept the alternative, it's less than. But then this is more than 0.05, right? It's more than this guy.
Yes.
So if it's more than that guy, and the mean is itself also more than anyways, then the null hypothesis is accepted, which means that he can open it. I kind of explain that in here. Okay, because the p-value is greater than the alpha, then we accept the null hypothesis and we should open the restaurant. This is the case because the site is, and I kind of gave like a reason why, because he says it right there. Does that one make sense? Yeah, that's how you look at these things.
Okay.
Okay, I think. Do you want to cover this maybe, or do you have more time?
Yeah, I got more time.
Okay, let's just cover it. I want to finish this. So if you take a look at part two, part two right here is pretty much it's telling you that, so you have this the same pizzeria, right? And then now instead of like the pedestrians, you're trying to look at the tip. Like now the servers are being tipped, and then they want to know if they should increase, right? Like what does it say here? Like what is the tip of the servers? The mean or the median, something like that. So he's saying that the tip here, the median is 16% and the mean is about 17% tip. So this is a new data. So I downloaded it here. So you got to do that. I think he tells you to do that. And then it's restaurant tips. So that's what I did. And then now when I talk about like confidence interval, we talked about that's just like the 95%, you can actually calculate that, right? Like this confidence interval, you can actually calculate that. So make a confidence interval for me the traditional way. And then what I mean like the confidence interval for the mean is, it doesn't have to be at the 95%. It can be maybe 2%, 5%, whatever, 92%. And then how you do that is two different ways. There's the traditional way, which is he's talking about here, and then there's the bootstrapping way, right? Bootstrap. So let me just define. The traditional way is actually just doing what I did here, the sample t-test. Do you know what a t-test is first? Like I think I didn't really talk about that much.
No, I don't know. I just heard about it.
So a t-test is used for small data. Like you have this sample data right here, right?
Yeah, like the one we have.
Yeah, right here. It's like only 6 observations. You have 6 observations. That's like a really small data, right?
Yes, that's really little.
And then like for a t-test, that's why it's called like t-test. I think it's like maybe tiny, but whatever. Like the t-test is also called student t-test. And then this is what we're running here. You can either do like a 1 sample t-test or a 2 sample like t-test. For this case, or one-sided, like either 2-sided or 1-sided. When you usually do 1-sided, which I think we did on the top here, we only did like right here, for the pedestrians, we did only like a one-sided t-test. So when you do a one-sided t-test, you usually do it if you have like your null hypothesis. If it's like a not an equal sign, it's like a greater than or less than, it's a range. And then if you want to do a two-tail or 2-sided, this is like when the mu is equal a number. You want this, because they're saying here, I want the mean to be 17, and I want to do some statistics if that should be the case or not. Like, or how confident am I in saying that the mean of the tips is 17%? That's all the same things. So, like when you're saying the traditional way of running the confidence interval for the mean, all you have to do is run a t-test. That's the traditional way. So we know how to do that. You have this t-test, and t-test is, you have this, this restaurant tips data frame. So you have this data frame right here, right? And then I want to know, I want to actually do a t-test on the, where is it? I think this is percent of tip, PCT of tip. So you do the same thing. You have the data frame, you have the $sign, and then you have the percent of tip. And then, like in this t-test, it wants you to do the mu equals 17. So that's what we do, right? Like 17%. So you put the mu here equals 17. And then the next thing here, it asks you, what kind of t-test do you want to run? So I want to run a 2-sided. So like 1-sided, like I said, is when you have a range for your mean or whatever number here. So, but then like you do this one is this is not a range. This is just a number. If it's just equal a number, then you do two-sided. That's just a
So
rule.
you randomly chose the mu 17.
It's given to. He says here he feels that 17 mean is ample for his employees.
Okay, good. All right.
He says it right here, like
Now I get it.
yeah. So the mu is 17 because he tells you. So it has to be 17. It's not like a range like the other one where it's like greater than 100. When it's like a range, you use a one-sided, either less than or greater than. If it's equal something, which is this guy, then you do a two-sided. So once you do that, and then you put in the confidence interval, which is given to you, he says do it for 95%. You just run it. After you run it, you get this t-test. Now, and then let me just before we were looking at the p-value right here, right? If we were to say like, is this acceptable? It's not asking for that, right? It's not asking for this guy. So like, if our null hypothesis here, maybe just to look back to it, is we wanted the mu equals 17, right? That's our null hypothesis, right? Does that make sense when I say it's a null hypothesis?
Okay, can you go back there because I get start from where you had moved to the two-sided.
Okay.
Yeah, right there.
So the two-sided, this is just saying that I have like a two-tail t-test and a one-tail t-test.
A two-time t-test?
Two-tail, two-sided.
Two-tail. Oh, okay, two-tail t-test.
Yeah.
Okay.
Let me just define what those are. Did your professor talk about those already? The two-tail, one-tail? Did he talk
could
about
have.
that?
Yeah, I could have because there I didn't go.
And then like,
but he was mentioning it in class today.
This guy, this is the one I was talking about.
Oh yeah, he had this in class.
So this guy right here is two-tail. This guy is one-tail.
So he was drawing this one in class.
So this is two-tail. This is one-tail.
Okay, got it.
And then a two-tail test is usually when you have something equal something. Like the mu is equal something, and then a one-tail is usually when you have it less than or greater than. And mu is less than a value, which is what? That's the same as that part one, right? Like, one we asked about the pedestrian. We talked about that one, right?
Okay.
But then what about the tips? What about the tips?
I know the tip had to do with the mean.
Yeah. So, and then the other thing is too, the one with the pedestrian, the one-tail. You're only dealing with positive people, right? You don't have negative people. There's no such thing, right?
Gotcha.
So that's a range, and it's also only one-sided, right? There's no negative people. So it's only the positive side. So that's why you use one-tail for that one. For the tip can be negative in essence, in a way. But then also the tip itself is it's only a number. You have to check like, on the left side and then the right side, it's only a number. So that's why you're using this t-test, because you're using that because it's a small group of sample, small group of people, small group of tips. And then you're using the two-sided, the two-tail, if you have it like a mu equals something, or if you have to check if it's like a positive or negative. And then you're using a one-tail, a one-sided t-test, a one-tail. If you're if you have like a greater than, a mu is greater than or less than, and it's not equal, not equal just one number, it's a range. It could be greater than or equal to, but it has to be a range. And then if you have it as only positive or negative, not both. Okay, so now let's take a look back to what we have here. So what we have here is the two-sided. So this is a two-tail, right? Because we have this mu equals something, right? It's not a range, it's only a number, right?
Mm.
And then how you make this t-test do like a two-sided t-test, you just say ALT two-sided. This is how you write it, the syntax. ALT
Oh, that's the formula.
That's the formula, yeah.
Okay.
If you did a one tail, this is the formula right here. This is the one tail. So the one tail one, I just want to say this is the one right here. So the mu, when you're testing this hypothesis for like a one tail, it's a little complicated. But like for the pedestrian, it's the same thing. You put the data frame, and then you put in the mu, whatever the mu was, it's 100, right? And then this ALT actually stands for alternative. So the alternate. So if you're wanting to check if mu is greater than 100, you have to actually put mu equal 100, and then the alternate here says it's less. It's this guy. It's a little weird, but this is how they programmed it. Does that one make sense?
Well, it's kind of weird to use that since this is something that is positive.
Yeah, but this is how they programmed it.
That's how they program it. Okay.
Yeah, because this alt right here is the alternative, which is less than. So this is gonna check if this is gonna be greater than. Okay, so for the one side, that's one side. Two-sided is a little bit easier. Mu is 17, you know that.
Mm-hmm.
And then this alternative, it doesn't really mean anything. It just means like two-sided. This is how you define a two-tail. It's two-sided. And then, you always define a confidence interval. So that's 0.95, right?
Yes. Mm.
And then you run it. And so once you run it, you get the two numbers that you want to think about are these two. 50, it gives you two numbers, right?
Mm-hmm.
And then, because you're going to be comparing this with the bootstrap as well, the bootstrapping method. So you have, and what do these two numbers represent? These two numbers represent the range, I think, of your tips, from like the left end, which is like 15.928 to 17.311%. It just gives you the confidence interval for the means. So the 95% confidence interval is a range from 15.98 to 17.31%. So that's how you do it the traditional way. Does that one make sense?
Yes. Mm-hmm.
Okay, so now let's talk about the bootstrapping. So this one right here, the bootstrapping, a way that you can do this is a little complicated. And so like the way it's using the standard, the way you would do it is you need to create, let me explain what it is first. So when you do bootstrapping, it's really just resampling many times so that you can get like a value. And for each one of those values, you have to actually get the whatever, the median or the mean. And then from that, then you have to find, like, it's like it's like breaking down the t-test in essence, but because you sample it many times as you want, and for each sample you're getting like a statistic. In this case it's a mean, and then for those ones, after you get like the means, then you want to get like the range, like your 95% in this case has to be between that range, like the 95% in between. So what they chose here is 2.5% and then 97.5%. And 95% is the one in the middle, right?
Mm-hmm.
So it could have been like maybe 1%, maybe like 98%, it doesn't matter. So let me just explain how I do that. So bootstrapping, does that one, like the theory make sense? Does the theory make sense at least? Like where you have to like sample it many times and then you get like the mean, and after you get the mean, then you just pick out a value there where your confidence interval is like in between. Okay, so what is this first one asking you to do? This guy, what is it asking you to do?
Okay, so the question, let me see, Bootstrap.
Okay.
Let's see. Okay, remove enemies. Okay, so here he says download the following code,
Yeah.
a movie, blah, 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 read a movie, and then read CSV file.
Okay.
And then number 2, after you download, he says remove NS in duration using the filter function. That's number 2 after download.
So, okay, I did that already.
Yeah, and then number 3 is saying I've written the code below to form the normal log likelihood function you should read through to understand what's happening. And then the code is there. And then he says, number 4, find the MLE for standard deviation.
Which one is this one? Like, are we talking about the bootstrapping one?
Is that not the one I'm looking, or am I looking at the wrong one?
Yeah, try look at the bootstrapping.
Yeah, I'm looking at the wrong one. I'm sorry. That's the one I was trying to send to you there.
Okay.
The hypothesis that remained behind that. I couldn't do everything. I tried to do it, but I didn't get anywhere much. Let me see here. Give me 1 second. Let me go in here and look at it. How do I minimize this to go to let's see.
All right.
Sasa kuletea zile zimebaki kule nimepaka 5. I think it's 5.1. Paul, how do I minimize the video so I can get to? Oh, there you go. I think it was
You got it? Okay.
Yeah, it was. I lost it again.
Okay.
Let me see. I need to work on so many things in the computer. Because I have it somewhere. I could show it to you. I thought I had it here. Oh, there's something. If I touch my mouse, I can see the bar of the window, the taskbar. Okay. That way I can click this and show you.
Did you open up the week 5 assignment?
Yeah, because I want to open the week 5 assignment, but I can't get to. I'm trying to click at the bar to.
Okay.
I'm trying to do it again. I'm trying to click the bar so I can get the 5 assignment.
Okay.
Okay, there we go. All right, so let me go here. Make 5. It's not this one. What does that one say?
I'm in the
looking for-
bootstrapping one.
Yeah, that's the one I'm trying to locate here.
I think it's like in the
Bootstrap.
I think it's in the bottom one. I think it's like well, it's gonna be a
The
different
bottom
line.
one.
Yeah, all the way on the bottom.
Okay. Okay, let me see. Okay, I see it in R. Let me see if I can see it.
Yeah.
Yeah, for the, because I see it as a download in R. I can't see it. Because I think when you click it, that's where I think I have an issue. When you click it, then it downloads to R
Okay.
directly. Let me see. Let me go into class directly. So I can, so you can see it live. Just 1 second. Okay, and then my door. Enter 120.
Did you see the bootstrapping one?
Yeah, I'm looking for it. Yeah, I'm just getting into pull it from there so I can open it. Okay. So I will go to this. Okay, so let me look for it here.
Okay.
So bootstrapping. Okay, it's this one right here. So let's open it.
Okay.
Okay, so here's what it's saying. Log file. Are you seeing it?
Let me see. Let me see. Are you sharing anything?
If you permit me to share, then you can see the screen exactly where.
Try to share. You should be able to share.
Okay, share. It says you cannot share the screen with other participants sharing. Why?
Okay. Try it now.
Okay, so now share. There we go.
Yeah, I see it.
Okay, so do you see it now?
Okay, let me see. Okay, week 5. Yeah, did you download this one?
Yeah, that one.
Yeah, click on that one, the week 5 assignment.
Okay, if you click, it downloads.
Okay, and then open that.
Open the download.
Okay. Now when you, it says there bootstrapping, right?
Yes.
Okay, so like, did you read through this one? Try to see if you can tell me what it's asking.
Okay, so the bootstrapping,
So it's all about the tips.
okay, 66. So it's saying, while you feel confident in using the standard normal methodology, as you explained above, Tony wants to get another perspective. He's heard of a technique called bootstrapping and wants to give it a try. The following steps will create a 95% bootstrap confidence interval.
Yep. Okay.
And then he goes to say, create a function called bootstrap that takes a sample of equal size n equals 157 from your current sample with replacement. Your function should return the mean of your bootstrap sample. This
Yep.
is mimicking taking any sample from the population and then give the boot sample function.
Yeah. So for this one, like what is, you need to create a function, right? You need to create a function, and the function itself has to sample a data that's like 157 size, right, of the sample. And then he wants you to make the, it needs to be with replacement, right?
Yes.
And when you're saying with replacement, that means it's independent. So that means like the
Oh,
next,
that's what it means.
yeah, when the next sample, like each sample you take from your data doesn't affect the other thing, like the other samples. It's like with replacement. So each one is independent. Each one is independent. For this one, it doesn't matter. The reason why it's saying with replacement is gonna affect your code. So
Okay.
so that's why it's saying let me just go over what my code is doing, and then let's talk about it.
Okay.
So what it says there is you have this boot sample, and in this boot sample, this is how you create a function, pretty much. So you have boot sample, and it's going to equal this function, and you have to feed this function a data, and this data is going to be your data frame. Does that one make sense?
Mm-hmm.
And so from that, inside this curly braces, you have to create your function, and that's what it's telling you. Your function should you need to create a function called boot sample. And then so this boot sample is the name of the function, and then here is like how you create a function inside here. So inside the function, I want this new data because it's telling you here return the mean of your boot sample sound, right?
Mm-hmm.
So this new data, I want to create like a new variable. Like I'm calling it new, and then I want this sample. So this is like the sample command. So I'm taking the sample from the data, and then this data is going to be your data frame. Does that one make sense? Like this function takes in
Yes.
your input here is your data frame, and then what I want to do is I want to take, it says take a sample of equal size, right, from your current sample. This is what it wants you to do. Take a sample of equal size from your current sample. Your current sample here is your data frame, right? So your sample, your data frame, which is data, and then you create this the equal size. So what is the size you want? You want 157, right?
Yes.
And the next thing you do is, what does it say? Replace equals true, because he wants it with replacement. He wants it with replacement. That's like, so
Yes.
that's how you take a sample from your data. You just use the sample command. You take a sample from the data using the sample command. Sample command it takes in 3 arguments. The first argument is the data frame, which is the data frame. What is that? The one that's given to you, the tips, the restaurant tips, percent of tips. That's your data frame. And then your number of times, because this is a boot sample, the number of times that you that you want to create from the sample, that you want to create from your, that you want to test using the boot sample, is 157 from the original data frame. You want to take only 157 of those guys. And then the third argument is you want replacement. And if it's with replacement, you just put in replace equals true. If it's without replacement, you can put replace equals false. And then so that right there is your new data. And what is it telling you? It says your function should return the mean of your bootstrap. Right?
Mm-hmm.
So how do you do that? Your function should return the mean of your bootstrap sample. This new data right here is pretty much my boot sample. This new data. I could probably put this as like new boot sample. I could probably put that one. It doesn't matter. So this new data, I put mean in it, right? I put mean of the new data. Because this is a sample. This is pretty much a list now. Right? There's a list of like 157 items. Right?
Mm-hmm.
And then I want to take the mean of that guy. So the mean of that guy, I could have done this another way. Like there's another way. Like another way I could do this is just doing this right here. Maybe I could just return this guy right here. Maybe that makes more sense. What do you think of this one? Let me just run this first. And let me run this. So, this boot sample takes in a data. This data, I'm taking 157 of them. And then I want it with replacement. And then I want to take the mean. I want to take the mean of that sample. And then I'm going to return it. Does that one make sense?
Mm-hmm.
So the first thing you did here was you took the sample of the data, 157 of them, and then you take the mean of that sample, and then you return it. The reason why you're returning it because you want it to you want this every time you call this boot sample on like any type of data frame, you want it to return. You want it to output the mean of your boot sample, which is 157 items of your data. Okay, so this is the function. Does this one make sense? Like, is the coding of the function make sense?
It's kind of getting complicated.
Yeah, I know. It's when you're creating a function, it's this is the syntax. The syntax is like what makes it very like it's unnatural. It's like so what you put in here is pretty much the name of the function. And then the next thing you do is you make it equal. So this is like your equal sign, right? But then you put in function. Like you have to put in function so that this boot sample is a function. And then inside this function is your data frame. So this data frame, does that one make sense? Like that part I think is the easiest one. So your name of the function is the first thing you write, and you make it equal a function. That's what it wants you to do, right? Create a function.
Mm-hmm.
Does that one make sense? Like you have the name of the function, which is boot sample, and then you're trying to create a function.
Okay, so then the name of the function is boot sample.
Yeah. One of the hardest things there is just trying to like accept the syntax. Accepting the syntax, sometimes it's like there's no rhyme or reason for like why you're doing it.
Mm.
But you just have to accept that this is the way you do it. This is the reason why coding is hard, because it's not English, you know. It's not like you just write it and that's it. Like you have to write something that works.
So my data there, the data frame Is 157, is that my data frame?
You're not yet. So you know when you're creating a function, it has to be a general function. Your data frame is down here, the
Oh,
restaurant.
okay.
What we're trying to do now is we're trying to create a general function called boot sample.
Got you.
Yeah, I'll cover more of the basics. This is like a basics of R of coding, creating functions. We talked about loops and if else if statements, right? We talked about variables.
Mm-hmm.
We didn't talk about functions though, right? We didn't talk about functions.
No, not yet.
But I'll cover that next time because I think I'm running out of
Yeah,
time.
we'll cover that next time.
Yeah, I'll talk about functions next and classes. Classes is another type of hierarchy.
Yes.
So a function is this is how you write it. You have the name of the function, and you make it equal a function keyword with, and then whatever you put inside here is whatever you're gonna feed the function. It's the input of your function. And what are you trying to feed in the function here? The data frame, right?
Yes.
So you put in the data frame. I mean, you can might as well put data frame in here. It says, actually no, maybe not. Don't put data frame because that's like a keyword, I think. So just put data, and then inside this data, which is, let's imagine right now this is the restaurant tips, percent tips. You take 157 of those, and then you make the replacement true, and then that's the sample, right? That's your boot sample, right? And it wants you to take the mean of the boot sample. So you just apply mean to the boot sample. Does that one make sense? You have the boot sample, and then you have the mean of the sample, and then the reason why you put return here is because you want your function when you call, you have the input of your function is what? The percent tips, right?
Yes.
So a function always has an input and it has an output. Whatever is the input of the function, that's what you're feeding, and you're doing something to it. And then whatever you want to get from your function is your output. And what that is whatever is inside return. Whatever is inside return is what's going to come out of your function every time you call that function. So boot sample is the name of your function. The input of your function is a data frame called percent tip. But right now we're making the function, so we need to make it general. So that's why we just called it data. And then this data, you need to create a sample from your data frame, which is called a boot sample. You need to create 150. You need to take only 157 of those and get the mean out of it. So that's the calculation that you're gonna do, like allow your function to do. Is you take the input data frame, you get the mean out of that sample, and then the output is the mean. The output is the mean of the sample, and that's how you put it inside the return. I know it's a lot of words, yeah, but
yeah, it can be confusing.
It's that is how a function that's like pretty much the theory of the function. That if I don't talk about the simple stuff, it's gonna get complicated. That's why. You know how we broke it down? We broke it down here, right?
Yeah.
And then we use like simple things.
Yes.
If we use simple things, I'll talk about it later. It's easier to understand when you finally apply it. It's really complicated because then they're assuming that you already know how to do it. You know,
How to do it.
yeah, they're assuming you know how to do it already. And if you don't know how to do it, then that's like really, it's like the hardest thing.
Yeah.
But we'll talk about it. We'll talk about it next time for functions because it matters here.
Okay.
So you have this boot sample and you have this function, right? And that's the, so
did you calculate it on the one you sent me back? Is it ready for submission?
Yeah, all of it is ready. All you have to do is change the name.
Change the name and then just submit it.
Yeah, that's all you have to do.
Okay, cool.
But like, just to talk about it, because I really want to get you to a point where you're the one coding it.
Yeah, where I'm the one driving.
Yes, yeah.
That's the point where I want you to take me.
Yeah.
Next time, yeah. So just bit by bit until you know I get it. That if you tell me, read this, and then I want you to create.
Yeah.
To start the coding, then I like.
The best thing I would probably do is you know how like we have like the video I sent you. I sent you a video, right?
Mm-hmm.
I want you to like do the video.
Yeah, I'm
Maybe
not watching, but I saw it.
like maybe do the video like the the video tells you to shows you how to do some basic commands in R.
Okay.
I want you to like maybe while the video is playing, pause it and then like try to type the things that they're doing and then see if you can replicate what they did.
Okay.
And then that's really how you practice the code. It's just learning by doing. You watch someone do it, you do it yourself, and then you repeat it.
Okay.
And that's how you learn these things. It's not like magic where okay, I'm gonna like read it and then I get it.
Right, right.
It's really not. Like code is very hands-on. You have to do what the person is doing. And then I was like, oh, now it makes sense. So, like that. So like, okay, let me just go over this. So this is how to do the function. And maybe like we'll call it a day.
Okay.
So let me just go over like the rest of this. So after you create the function is general. Maybe just ask me general questions. Like, so after this one, you have this function here, right? The boot sample. This boot sample is what you create up here. And when you call this guy out now, it's going to give you these guys. I'll explain what this is. Because this is what it's saying. Create 1,000 bootstrap samples. And you want to put that inside of boot means. Boot means is like the variable that you want to store this 100,000 boot sample means. And then he wants you to use replicate. You could use another function, or another command. But he wants you to use replicate. And how you use replicate, it takes 2 arguments. It's really simple. So replicate has 2 arguments. The first argument is how many times you have to run it. Really simple, right? How many times you have to replicate it. It's 1,000 times. So you put 1,000 here. The second argument is what you're trying to replicate. And what are we trying to replicate here? The boot sample function, right? Like it says here, create 1,000 boot sample means. The boot sample function creates a boot sample mean. So you create you apply boot sample function inside, and inside is the data frame, right? What are we feeding the boot sample function? A data frame, right? And what is the boot sample function gives? What's the output of the boot sample function?
The mean.
The mean, right? The mean of the boot sample. So when we feed it the data frame, the output should be the mean. The output should be the mean of the boot sample. And then this is telling you, run that 1,000 times. So I run it 1,000 times and then put it inside boot means. So now this boot means, which is what you see here, it's being printed out, is 1,000 of these guys, right? 1,000 of these boot means, right? So that's what we have. And then the last thing is, what is it asking you? It's asking you, now I want you to find the confidence interval. The confidence interval is, you're saying it's 17, right?
Yeah, 17%.
Is the confidence interval mean. And then so that's 95%. You're confident that the mean is 17%. So if that's how you do that is just you want to get these 2 numbers, and these 2 numbers is the percentage of like where the range where your 95% mean should be in between them. And he says that I want you to put 2.5% as well as 97.5%. And the function for that is quantile. The function for that is quantile. Your professor, did he even talk about this quantile thing?
No.
This is like, yeah, that's pretty tough because like he gives this to you and then he doesn't talk about the functions that you're supposed to use. That's like giving someone, it's like, hey, go ahead, do this, and never explain to you what you're supposed to do.
Gotcha.
That is crazy. Because like he's assuming you know how to code in R already, probably. I don't know.
Yeah, and I have no clue.
So in order to do that, so you have this quantile, and you have this quantile, and then what you're feeding this quantile is 2 things: is whatever lists that you want to get, like the 2.5% and the 97.5%. So you have this boot means, right? You have all these guys, right? 1,000 guys, 1,000 means. So you feed it 1,000 means, boot means, and then in here you put C because it's a list. It takes in a list. So it's 0.025, which is 2.5, and 0.975. And then you do this whole thing, and then you get this as the output. So the 2.5% confidence interval mean is 15.9, about 16, and then the 97.5% mean is 17.4. So that's the result of your Bootstrap confidence interval mean. That's really what you have, what you're supposed to do. And you were supposed to replicate what you did with this normal distribution. The traditional way of using a t-test, this t-test. And what you found out here was these guys, right?
Mm-hmm.
You found out that like your 95% confidence interval is between 15.9 and 17.4. And what did you find out here? This is pretty coincidental, right?
Yeah.
15.9 and 17.4. That's pretty close, isn't it?
Very close.
And that's when you know you're right. Because if you're wrong, then that would suck.
Yeah, see that.
And then, so what now? What does this tell us, right? I think it's just saying discuss how this interval compares. So you're just gonna discuss it. And what is saying that the bootstrap method works similarly to the traditional method. And the traditional method is doing the t-test. That's the traditional method. This way we didn't do a test. We did the bootstrap way. Where you replicated 1,000 or number of times your bootstrap mean, and you pretty much took the interval from there. And then this next few ones is pretty much doing the same thing, but then with the median. The only thing that changes is this function right here, right? The function is the only thing that changes, right? Because then it's like the first one you did boot mean, right? And this one is gonna be boot median.
Okay, so now we have the boot median.
Yeah, so this boot median, the only thing that changes is your function. Because the first one, and then everything is the same. Everything is the same. And that's pretty much it.
Okay. All right. Then I just change the name and then just submit it, and then I'll send you the checkpoint. So, because he will need it by tonight. I told him it was behind because I was not still working.
Yeah, no worries. Just send that to me and I'll take care of it.
Yeah, and then the week 6 is for tomorrow. It's due tomorrow.
Okay.
Yeah, I'll just send you everything. But I just.
Do you guys have like how many times a week do you guys have homework? It's like a lot of homework.
Well, we got like per week we have like 4 homework.
I see.
And then if we happen to meet on a Saturday, because we don't meet every Saturdays, we meet every Wednesdays. Okay. But if we meet on Saturdays, then we have that extra work, so it makes it 5.
Okay, that makes sense.
Yeah.
Do you when do you want to meet again for our next session?
Well, let's knock it out on Monday.
Okay. What time on Monday? Do you want today kind of like went pretty long. Do you want to do 2 hours on Monday?
Yeah, we can do 2.
Okay.
And then plug in. Are you available in the morning or the afternoon? Because I can.
I'm only available in the afternoon my time.
Okay, then let's do that afternoon your time, which is good.
Okay.
So we start early.
What works during that time?
So let's say your afternoon starts from like 4 my time or 5 my time.
Probably like, let me see. Right now, I actually don't have anything for Monday, so maybe let's do like 5 my time.
Okay, so then 5 your time plus 3 would be 8.
Yeah.
My time.
So like maybe 5 to 7 and 8 to 10 for you.
8 to 10.
Yeah, does that work?
Yeah, that's fine.
Okay, let me just book it now. Okay. Okay, I think that's pretty good. We should just do it like maybe twice a week because like this is a lot of
Yeah, twice a
material.
week. Yeah, twice a week. That way I can catch up in my understanding.
Okay. Okay, I just booked it and then yeah, like please ask me anything. Send me all your stuff and then I should be able to finish that today. And then like
Okay, cool.
is it coding or is it just a quiz?
It's actually what you're gonna deal with now is going to be based off of the one we just discussed.
Which one?
This lock data.
What is that? What what is the like just send it to me. I'll probably look at it.
Yeah, like the movie thing that we were talking about. Yeah, it's like it builds on that. It just builds on that.
Okay,
On
I'll look at it. Okay, hi Marianne. Very nice to meet you and then like I'll definitely help you. Well, we should do twice a week because
okay, cool.
there's
Yeah,
a lot of
that's what.
homework and then it's gonna build up if we don't like next time on Monday I'll talk about the functions
Yes.
and then like we'll go over like do you guys have any other coding that you have to do?
Yeah, like let's do the functions, the classes.
I think for the classes I'll hold off on that because I haven't seen it yet. I haven't seen you guys do classes. Let's just do
Okay.
functions first.
Okay, then we'll yeah, let's do functions. And then he also mentioned something like normal distribution type thing.
Okay. Oh yeah. After we do the function, I'll talk about more about each
Yes,
individual distribution, like normal distribution.
yes,
And then there's
those,
other ones, right? T distribution. There's
yes.
geometric distribution.
Mm.
And there's a lot of them, right? And then
Yeah,
Poisson distribution. Yeah,
yeah,
yeah. Let's talk about those ones. I think it'll be helpful for the coding. Like, let's talk about the how you code those.
yeah, then how to code those.
Okay. All right, Mary. Thank you so much, and then I'll send you send me your homework, and then I'll help you out soon.
All right, cool. Thank you so much. Appreciate you.
Yep. Okay. Cool.
Bye, Paul.